Hello everyone and welcome to the C# 101 Week 6, the final week of the C# 101 class. Though I say that, but in just a minute I'll have an announcement in regards to how we really are going to be wrapping this up, because I don't want today to just come to the end and be like, that's it, and thank you very much for playing. I want to make sure you guys actually learn something if we're going to give out certificates to you. So yeah, today we're going to be talking about object orientation, finally. So OOP, or object-oriented programming. As always, joining us we have both Nelson and Gavin. Hello, gentlemen.
Hello.
Hello. All right, so some real quick announcements. The first thing, for those of you that have seen, we did put up the C++ registration for the 101 class. We ended up using the Monday time slot that the C# 101 class is currently in, and we'll probably alternate it back and forth when the next C# 101 class comes about. Once the C++ one is done, we'll probably start that back at the Monday time and then just switch back and forth between the two to try to accommodate people. This time around, we're trying something new with C++. We're giving up, well, I'm giving up part of my Friday night to, so we got C++ on Friday nights as well, starting at 7 p.m. Central Time, to try to help as many people as possible, time-wise. So that gives us 2 days a week. Again, originally was not going to have two classes of the same in a week after, doing this with the C# class, but C++ has had such a high demand, I decided to go ahead and do it to be as accommodating as possible for everyone around the world. Blender 102 is going to be moving to Tuesdays, and we'll have the kickoff date. Right now it's probably going to be next on the 10th of April, so next Tuesday. The funny thing about that is you guys will not be getting much time, for those of you that are in this class, between the 101 class and the kickoff of the 102 class. But that's tentative. I'll let you know for sure here in the next day or two. I'll have that information. The C# 102 class is currently it's being looked at as a Thursday class. I do not know the exact time. Nelson had said that we had talked about doing it earlier in the day, like we're doing this one. I don't know yet. If you guys have any thoughts on that. I mean, of course, I would assume that most people's thoughts are going to be for early, for the simple fact that this is our early class right now. But anyways, we are looking at Thursdays for doing that. And Nelson, is there anything else that you can think of in regards to upcoming stuff before we talk about the end of C# 101?
No.
Okay. Well, the end of C# 101, this is important. You're going to have homework at the end of today, so we're not just going to say, hey, that's it for class. We're going to be meeting up next week for taking a test. That's right, ladies and gentlemen, for taking a test. You do not have to take a test if you are not interested in getting a certificate. But if you have participated in the 101 class and you have done the attendance and you've turned stuff in, you need to take the test and you need to pass the test in order to get the certificate, and that is extremely important. Test time will not take long. I mean, it's only going to be about 800 questions. Maybe 9, I don't know, it just all depends on how many we come up with. Just kidding, it won't be that many questions, but it's going to be enough to make sure that you're walking away from this class with a 101 knowledge. It will be timed, and it will be available to be taken on the web. So yeah, there you go. And if you fail that class, but you've attended everything, you've turned in homework, and you fail the test, don't worry. You're going to be able to take it again if need be by coming in the next day. I'm going to let you know the times that we're going to schedule next week. And the only reason I'm having to do that right now is because, as a lot of you know, we're kicking off the C++ 101 class next week at this time. So I'm going to give probably, I'm thinking at least 3 different days with different hours that you can come in and take the test. So you will need to be using time to study. Yeah. Sound good to you, Nelson? Sounds good to me.
Yeah. Well, I kind of like the 800 questions, though.
Oh, do you? Well, then I guess we'll have to have 800 questions. It's going to be challenging to come up with that many for a 101 class.
That'll be fun.
All right. So there's a couple of questions that came over in the questions panel. One, Mr. Barry has said, is it a bad idea for us noobs to learn C++ and C# at the same time? Nelson, you have any thoughts? It's a good question.
It really depends, I think. The C++ and the C# class are both, they're both in the subscription that you have, so you could try it out, and if you like it, you can continue watching it. A lot of the things in the Intro to C++ class, however, are going to be very similar to the Intro to C# course, obviously with different syntax, different libraries, stuff like that. Then things, though, start to diverge once we start talking about pointers, for example. That being said, learning the concepts of pointers and manual memory management are actually pretty good concepts and will really solidify your understanding of a lot of different things that could be very, very much applied to programming in C#. So once you get past the sort of intro stuff in C++ and get onto things like pointers, that knowledge is beneficial when working in C#. In addition, you'll also see reasons why you would want to use C# over C++, specifically, the amount of code you have to type to do a particular thing. So it's really up to you. I wouldn't say it would be bad. What are your thoughts, Jason?
No, I don't think it'd be bad at all. I think watching it would be good. Perhaps, it's a 101 class. You'll be surprised already how much you're going to feel somewhat at home with, the concept of what a function is. Once you're, comfortable working with methods, and you're going to understand what variables are. And still a lot of what's going to be taking place is learning to logically think. And that's the biggest problem, in my opinion, that a lot of noobs suffer when coming into the world of programming. It's one thing to get the syntax down. It's another thing, though, when you sit down at the computer and you've watched Nelson for, type for 2 hours, and it was like, oh, that's so easy. It all made great sense to me. And then you sit down and you get ready to type, you put your fingers up to the keyboard, and you're like, what am I going to do? And you draw a blank, and you understand the syntax, the simple stuff. You look at other people's code, it makes sense, but it's learning to think in such a way that, logical thinking, that you can start structuring a foundation for a basic app. And so you're going to get even more of that in the C++. So I don't think it would be a bad idea at all. At the same time, if you find yourself getting confused between the differences in the two worlds, then maybe you could drop out. You guys are member sponsors, and every class is open to you. So my thoughts are, if you have the opportunity, you have the time, take advantage of it and see what you think. For there, going on to the next one, Gavin, if you want to take that one, it's a homework related question.
It's actually a typo related question. It just was homework slated for Wednesday, April 3rd, but it's the 4th on Wednesday. Is the date or day wrong? No, I've corrected that now. It's Wednesday the 4th.
And Mr. Andrew Thompson asks, is it C++ 11? And the answer is yes. And
keep in mind, we're not going to be talking about move constructors or left-hand values or
it's a 101.
Lambdas,
it's a 101 class. Keep that in mind.
Yeah, a lot of the C++ 11 features are.
But there are some basic. I know there are some basic ones that we're still going to see that we've put in.
Yeah, and we will be conforming to the syntax of the standard specifically so that we can do true cross-platformness,
right? Where
the same code that we write should compile against Microsoft Visual C++'s compiler and GCC's compiler.
And that's one of the things that I took a lot of time and great pain to make sure that the beginning of the course is structured in such a way that we're going to accommodate everyone. So we're going to be looking at Xcode. We're going to be looking at Visual Studio 2010. It wouldn't surprise me. At some point later, of course, we switch over to the newest Visual Studio. But for now, we'll be using 10, and then we'll be using the wonderful world of G++ as our compiler over in the Linux world. So we just want to make sure that, we accommodate these three different platforms, and that should make things really interesting for people. Let's see. All right, what else do we have? Mr. A. Enrico asks, how long after taking the test will we get the results? How about instantly? That's what we're shooting for, instantly. Let's see. Mr. Glenn, if you fail one of your homework, then there's no use in taking the test to get the certificate. Whoa. If you fail a homework, you should have corrected your problems and submitted it again. Turned it back in again. Right, Gavin? I mean,
Yep.
We've made it available, so if you fail something, fix it, resubmit it. So if you failed something, fix it, resubmit it. And Ian asks that at the end of the test, if I fail, will I be told which questions I got wrong? Yes. And yes, we are going to be talking about some of the newer C++ 11 concepts. So I think that's everything over in the questions panel. And everybody just relax. It's all going to be good. I know this past week we did not have an open office hours, and I apologize for that. That will happen from time to time because it is an extra thing where it's, if we have time. And this past week we have just been so swamped that it's been crazy. But I did want to point that out real fast. And with that, Nelson, you ready to go ahead and get things kicked off with an introduction to object-oriented programming?
Yeah.
Where's the excitement? Yeah.
Oh, no, I was having a small little conversation, tangentially related conversation in the chat, but...
Was there anything that you want to say out loud for all of the students to hear?
People were just saying that they like header files, and I said that header files are the reason why C++ takes significantly longer to compile projects than C#. Same thing with templates. Mm-hmm. The way that the C++ compiler compiles templates is kind of horrid and takes forever to compute, whereas with C#, generics are runtime.
Right.
And handled during runtime, not during compilation. As a result, the C# compiler is significantly faster. But, okay, so object-oriented programming.
Everything's an object. The end.
Yeah, it really is. I mean, you've already...
no.
Well, okay, go ahead.
But you said...
Is null an object? I just want to point this out really quickly. C# is not a fully object-oriented programming language.
So null can exist outside of a class as a usable thing?
It can't. It's just a value. So it's not an object. In Ruby, nil is an object, which I always thought was fine.
Oh, you were just so dying to say Ruby. I understand. I'll let you off this one time.
Well, I just wanted to point out that
exists.
Every variable that you can reference is an object. Every variable, every value specifically is an object. And we've already talked kind of about what objects are. So, for example, we have a variable. And this variable is an object. We can tell it's an object because it has members. We've also looked at this, the example of the first class that we instantiated. So everybody kind of remembers what we're talking about with instantiation.
Some are going to say yes, and then others, I'm sure, are not going to say anything, but they probably don't know.
Alrighty. Well, in the case of line 12, C# has a literal syntax for integer values. As a result, we can assign literal integer values to integer variables. But this type right here, specifically this class right here, isn't something that C# has a literal syntax for. As a result, we have to use what's called the new operator to instantiate this class. When we instantiate this class, we get this mylist variable to contain the functionality and data of what a list is. This is called instantiation, and you can tell it's instantiation because you have the new operator followed by a type, and in this case the type includes the generic arguments. This is what's called a closed type, and then followed by parentheses to invoke the constructor. So this is an example of instantiation.
To instantiate something in the real world, we could have a set of blueprints for a house. And those blueprints would represent a class if you were to compare it to the object-oriented programming world. And then for that house to actually be constructed and brought into existence, we basically build the home from the template or the class or the blueprints. And now we have an actual house that's now standing there that could be painted its own color, basically having its own state set. But now we have a real house that we can walk into. Same thing that's going on here, where list is nothing more than a class, a template, and we are constructing a new object, a list type object from the list class. And so if we were to translate this into the real world, we were going to make a new house, and we would say my house equals a new house, and we'd be constructing a new house from it.
Yep. So I just kind of, before I launched a more general discussion about OOP, I just wanted to get what Jason just said just across in the context of something we've already done. So like Jason said, we've created a new object that has the functionality and behavior and data of a type in the .NET framework that allows us to perform specific operations, in this case, adding and removing and clearing items. So this is an example of an object. My list is an object. Object-oriented programming is the concept of constructing a program based off of the relationships and interactions between a variety of different objects and different kinds of objects. If you think about the real world, how let's say you have a car. I mean, you have an instance of the car blueprint and you interact with your specific car, for example. But your car is made up of a bunch of other things that were constructed from blueprints, such as your tires or your wheels or your engine and so on and so on. So you can kind of break almost everything you can see in the real world down into a hierarchy of these complex relationships between different discrete objects. Now, the goal of programming at a very high level is to model some part of the real world in code, give that modeled data, and in some way present the output of that model's computations to the user. If you break down every program, every game, every application, that's essentially what it does. So the goal of programming is generally going to be to create a model of some sort, to model a subset of the real world, to identify the things that you care about and describe those things in code so that you can interact with those things with logic. And object-oriented programming is a methodology of creating these what are called objects that have complex relationships and interactions with each other. Now, a lot of specific programming languages, such as C++, C#, Java, Ruby, Python, PHP 5 specifically, and so on, have a bunch of facilities, a bunch of tools that allow us to very easily describe a simple to complex model or a problem in the real world in code using the concepts of types and objects. Now, that doesn't mean that object-oriented programming is restricted to languages that support it. For example, you could do object-oriented programming in C if you wanted to, but you won't have any language features to help facilitate the process, and as a result, it'll be annoying. Or you can use languages that pretend to be object-oriented, like Cold Fusion, and end up banging your head against your keyboard for days straight. Or even use a language like JavaScript, which I have no idea what the people were thinking when they wrote it, but it has a very, very odd definition of what an object is, but you can still describe an object-oriented system with that language. Now, fortunately, in C#, we have a bunch of really awesome facilities at our disposal that you will have to become intimately familiar with if you want to be successful in writing C# applications. The most important one is the class. And we've already been writing a class. Now, in C#, every bit of executable code you write is going to be inside of a class. Now, there are other types like enums, for example, or interfaces, or delegates, or whatever, or structs, which we're not talking about structs here, but structs would be another place you could put executable code. But we're focusing right now on classes. Classes are where you will generally place your executable code in your applications, and you are forced to. So between classes and structures, there's no way to write free-form code. Now, for example, in C or C++, that would be acceptable. You could write a, this is what's called a function. It exists outside of any type, but it's impossible. Blah, 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 blah. There you go, Segfault. And anyway, the point is you cannot write free-form methods outside of types in C#. That's impossible. You are forced to write them inside of types. And this is very similar to how Java works, for example. In Java, you cannot write methods outside of types.
Now, Wolf Knightley just asked over in the questions panel, what about enums? And Nelson's talking about executable code.
Yep.
Not the definition of a new type.
Yep. Enums, unlike Java enums, which I'm still very envious of, enums cannot contain executable code. They only define the values that can go inside of the variables of that type.
And we've had another question come in as well, a couple. One from Ian.
Does that mean that all variables that have values are objects? Yes. Just because I like being really technically correct about things. If you don't want to hear what I'm about to say, just close your ears. But kind of, there are some situations where values might not be objects, but if you ever treat a value, any value, like an object, even if that object, or even if that value is by default just a piece of data and doesn't have any object metadata associated with it, it'll automatically be promoted to an object if you use it as such. So practically every value is an object. Technically, there are situations for performance reasons where the C# compiler will not treat a value like an object.
And then finally, Mike asked about running another program, basically a standalone for BuzzNet, the way we originally had done it instead of a web-based version because of the difficulties having. And right now, just because we're so limited on time, we're not going to be supporting the standalone version. But it would be nice, Mike, if Nelson and I could find some time to perhaps work with you to see if we could set something up for debugging, Nelson, to see if we can, because apparently he's seeing the problem happen quite frequently. And if it is something that's very frequent, then perhaps we could set some debugging up and try to get to the bottom of what's causing it. Because he's running Windows 7 64-bit with IE9, and it's running smooth for most people. Yeah, he says it happens every 2 to 3 minutes now, so I would be interested in what's causing, that particular problem.
Right. Oh, yeah, if you try a different browser, that might help.
He said he's tried that too. So I'm curious if it's some sort of another app that's running on his machine. But that's like some type of firewall or anything that, it's hard to say. But like say we have other people right there, Rowdy Bull's running Windows 7 IE9 x64, and it's running fine. And it's also run fine for me in IE9 as well. But so it'd be nice to kind of work with Mike at some point and see if we can figure out what's causing it on his machine, because that would be helpful to know for other people in the future as well. Okay, we'll get back with you on that, Mike, but let's go ahead and continue.
Yeah. Okay. So, just to recap.
Did you see Enrico's question?
In C#, are objects the same as classes? Good question. The answer is no. Objects in the context of object-oriented programming are simply variables that have data and behavior. And that goal of a variable containing both data and behavior, such as, for example, the MyList. MyList contains both data and behavior. For example, we say mylist.add 10. not only are we using the behavior of add, we are modifying the data that my list contains by adding 10 to the item. So in abstract sense, an object is a value that, or a variable that contains data and behavior. Now in C#, the way you create objects. Now this isn't, like I said before, this isn't true for all languages, but in C#, the way that's supported to create objects, the standardized way, the built-in way using built-in language constructs, is defining types. What you do is you define a type, like you define a class, and then you tell the new operator to give you a new object of that type. Your type is going to describe behavior and logic in a very abstract sort of way. What happens then, though, is when you need that behavior or data, you ask the new operator to instantiate your class for you so that you can perform operations. I want to get that distinction between classes and types, or the distinction between types and objects that distinction is very, very, very important. Now, remember, objects in any language, the abstract definition is that an object is a variable that contains behavior and data. In C# and in many other programs, types are what we use to define what our objects are going to look like. Because C# is a statically typed language, that means that all of our types need to be defined to the C# compiler in full before they can be used. Again, not true for all languages, but still. Okay, so is int my variable 10 a shorthand way of saying int my variable new 10 because int my variable is instantiated? That's a good question. It could, if they wanted to, they could have done this. They don't support the syntax. New has no constructor that takes in a value. If they wanted to, you could do this, but because the only way to create an integer value is by using the literal syntax. I want to point out, though, that this isn't instantiating, though. In this case, this is not instantiated. And the reasoning for that is a slightly technical discussion that we are, I don't think, getting into the difference between value types and reference types, Jason?
No, not at the moment.
Okay, so yeah, maybe later we'll go over the specific reason why.
I say we do later, but today.
Okay. There is a specific reason why this isn't technically instantiating anything, although it would behave as if it were in certain scenarios. Is list a type or a class? You call it both. That's another good question. A class is a kind of type. There are a variety of different types in the C# programming language.
An enum is a type. A class is a type. A delegate's a type.
An interface is a class, or an interface is a type.
Slap you.
A structure is a type. Those are all different types of types or kinds of types.
Is a type a type?
Well, there is a type. It's called types.
So you can do type of type.
Type of type.
Okay, let's stay a little more focused on what our beginners need to hear.
Okay, so but yeah, the answer to that is that list is a class. We know list is a class because well, we know it's either a structure or a class because we use this syntax here to instantiate it, and then I happen to know for a fact that it is a class because that's what documentation says, and same with the source code.
Do you like that movie, Nelson?
I
couldn't help but continue.
I still did. I just didn't like. I still don't like the name.
Yeah, no, I'm just kidding. Let's stay focused.
You wanted to, yes.
Let's stay focused. You were just taking a break, a breath. I mean.
Okay, so I'm going to toss some code up on the screen.
What I want you to do, Nelson, I think that would be a really good thing, is not type a whole bunch of random characters like that. But you had mentioned earlier about a car. So how about making a class of a car? Because you're setting up the blueprints. Because then we can start talking about members, and we can show how to actually instantiate the car.
Okay. Now, I do want to point out really quickly, this is something that confused me when I started learning object-oriented programming. And in fact, every new language feature that I have learned over the years, it has always, well, I've stopped asking this question because it happened every single new language feature I learned. And I'm sure it's happening to everybody out here right now who has never heard of this. And the question is always why? Why do you need new methods? Why do you need for loops? Why do you need types? And then why do you need, in C++, why do you need pointers? And then C# again, why do you need generics or delegates? You're always going to ask that question. And I want to point out here that this is the most important feature, or one of the most important features that you are going to be using very often. And I highly, highly suggest that you immediately start thinking about your program as a model, as a representation, as an approximation of the real world. And you use the tools inside of the C# programming language to express that representation so that you can perform logic in a way that's clear and concise and readable. So what we have here is a type that we're creating, specifically a class type that we're creating. Like most constructs in the C# language, and including what we've been seeing already with this, we start out with the keyword class followed by an identifier that we're going to use to identify our class. Now again, this uses the same casing as our methods and our program type. So inside of these curly braces, we can place what are called members. And a class is simply a collection of members. Remember how I said an object during runtime is defined as data and behavior. Well, how do we define the data and behavior in the C# program language?
And that's fine, Nelson. Let's also start drilling this into their head: state and behavior.
Yeah, state and behavior.
I'm a big fan of saying it that way.
So an object, remember, this is an object. MyList is an object. It works during runtime. It is used during runtime. And this at runtime contains state and behavior. It has
state and behavior, but at definition time, or right. Where Nelson's up there defining our car, he's going to be defining the ability for state and defining behavior.
Yep. So I'm going to go ahead and let's keep things really simple right here. Now you want to name your car, and let's say, actually, I do want to point out, just because, again, I'm also trying to drill in the fact that what we are doing is we are creating an approximation of the real world to complete or accomplish some sort of goal. So I guess it might be important here to define our goal. And our goal is to represent, let's say, a list of cars that we can display to the user. Then we have to ask ourselves, okay, we're obviously not going to be creating a class that represents a real car in its entirety. Again, this is a model or a representation or an approximation of the things we find important for our particular problem. And in this case, we want to name our cars. We want to know what year it was created in. We want to know how many doors it has. Is there anything, or let's just go ahead and add in color.
And that's good enough for a state.
Okay, so what is this?
Delete it is what it is.
Okay. We did have a question. If two off-topic, so in C# objects are equal to class in C++ and class. No, C++ and C# both share the concepts of classes and objects. Remember, an object is a runtime variable thing that is executed during your program's execution. Class is the definition of what that variable can do. I should make color into color.
No, let's keep it along the lines
but yeah, okay.
of what our beginners have been taught, not those of you that happen to already know more than what the 101 class is supposed to be teaching.
Okay. So what we have here are what are called fields. Now, you notice that we have variables. We've been using variables quite often. I mean, at this point, everybody should be everybody should be fairly comfortable with the concept of variables. What's up here are fields, and they look deceptively similar to variables in that they have types and identifiers. But they also have a few other things. One of the other things that it has are what are called modifiers. And modifiers are keywords that appear before the field that modify what the field is actually defining. The public modifier, we're going to be talking about accessibility at some point. So I don't want to get into it too much right now. But the public modifier applied to a field, or any member in fact, means that this member is accessible from any other location in your program, as opposed to this field or member only being accessible from within the type itself. So we have these fields, and it's important to know the difference between what I would be calling a local variable and what I would be calling a field, because they're very, very, very similar. The biggest difference is these aren't variables yet. What this is saying is if I instantiate a car object, he's going to have 1, 2, 3, 4 variables on him. If I instantiate another car object, he's going to have 4 variables on him, but they're going to be different variables, different sets of variables. So again, this is a template of the variables or the data or the fields that our car object can contain. But I also said that classes can contain behavior too. So what does behavior look like? Well, this should look familiar as well. So we can now add behavior to our class and actually give it a method that it can that we can use on it. So what's going on here is we created a method just like how we create the main method, but you'll notice a very important difference is that there's no static keyword. This could be static, but it would actually change the behavior of what this method means right now. For now, we're not going to be talking about static. This method is going to be available on every single car object we instantiate. So remember, we instantiate a car object. We get 4 variables automatically that are nicely packed up into this object. We also get this method, and this method has access to all of these variables of this particular instance. So let's go ahead and see what happens when we use this object. And after this, I think I'm going to have people type it out and go on and ask questions.
I concur.
All right, so I'm going to go ahead and hit the reset ready button. And let's go ahead and
Barry,
have
you may
everybody
not
type this
you
out.
may not name your cars, but I name mine. We're going to take Veronica out for a spin tonight.
Should take Veronica to the Lake District.
Yeah.
You could go to Keswick and Cockermouth. And
Whoa, okay, yeah. All right, so I'm going to go ahead and pause the video for just a minute while everyone is getting this typed out. I've resumed in case you want to answer some stuff.
1 minute.
Hit 1 minute if you're still actually typing this out, so we know who's doing what. And if you've done, please make sure that you hit the I'm ready button.
Okay, so a few people are still waiting, so I can go ahead and answer questions. And I did see a few questions in the chat, and I'm going to answer them, but please put them in the webinar if you can.
Birdie,
okay.
please.
And if you can't, I'm intrigued as to why not.
Yeah. Where's that question? Oh, okay. JT Burke says, it's too late now, but would it have been better to use this dot to start with? No. I mean, we'll get into what this is, but I never have to use this dot. Jason does sometimes, but I never have to use it. It's also a personal preference thing. And that actually, interestingly enough, that leads into the next question by Barry Ralphs, who says, do fields use an underscore in their identifier name? I mean, if you want to answer the first part of that question, or at least give your thoughts, Jason, because you and I differ on this.
I try to follow the convention set forth by the language developer with each language. And with C#, Microsoft's convention that they suggest that you follow is not using underscores for your fields. But of course, but without using underscores, this does force you in a position in things like constructors where you do find yourself using this dot.
Right. And I do use underscores. I think that it makes my code. I have a much better time reading through code that uses underscores, in my opinion, because it differentiates fields from parameters and local variables, but that's a personal preference thing. Just whatever you do, don't use M underscore.
Yeah. Wow, that's been a while.
Jason and I can agree on that. And more specifically, though, those are only for private fields. I do want to point that out. We have public fields right here, and the naming convention of any public member on a class is going to be this, what you see right here. It's not, I've never seen a person ever prefix their public members with anything. So yeah, this is the style of naming any public member. What is the difference between a field and a property in a C# class? We will be getting to that, but there is a very big difference. You mentioned people abusing fields in the last week. Are you going to explain what you mean about that? Yes. That gets more into a sort of design discussion about how you would go about deciding what should be a class, what should not be a class, what should be in classes. And we're going to be talking about that later once we sort of establish some of the syntax first. But shouldn't it be with lowercase? No. The reason it shouldn't be is because they're public. Public members in C# follow this convention. I've never seen anybody differ from this. Okay. So this is cool, I guess. We have a car object, and it contains these awesome variables. And notice how I said this car object contains these awesome variables. The car type, or the car class, contains these fields, which, again, is just a template. It's saying whenever we ask for a new car, give us these members. Let us use these members. So I guess another thing to talk about, or another thing to bring up really quickly before I ask for questions, is you can have as many instantiated objects as you want of your type.
Again, when we have a blueprint for a house in the real world, we're not limited to being able to construct only one instance of that house.
The coloring on that's going to be terrible.
So you see, we have two car objects. Now, is there any more questions? Is everybody good? More specifically, is everybody good with the relationship between a class, a type, and an object? What happens if you never define a field when you instantiate a class? You can create classes that have no fields if you want to. Are you talking about defining a field like what you see here on lines 10 through 14, or 13, or are you talking about setting a field like what you see on lines 16 through 29? They'll be defaulted. For example, if I remove this year, it'll default to 0, as you see name dash a year 0. So when you instantiate an object, when you instantiate a class, all of its fields will be defaulted or initialized to the default value unless you override that behavior, which you can do. But I want to keep things at least, simple for now, I guess.
What you couldn't do, for instance, is add in an extra line at 30 saying car.engine size equals 1.2,
right.
Because
that's another good point. So if I said engine size equals 321 and tried to build, I'll get a compilation error. And the reason is C# is a static language. Well, mostly a static language. And because C# is mostly a static language, we cannot access members that are not defined on the type that our object is instantiated from. So we cannot access the engine size member from the car object because the car class that we instantiated the car object to, or we instantiated and then assigned to the car variable, does not have an engine size field defined on it, or an engine size property. Okay, can you only instantiate other classes from the class that contains main? No. In fact, if I were to, for example...
Let's make an engine class.
Yeah, if I were to go ahead and create an engine class and then make a public void start or... what I can do here is I can go ahead and say public engine, and give it an actual create a field of type engine, which is this class called engine. And if I were to go ahead and create a method called you see where I'm going with this, right, Jason?
I do, because you're going to use this to segue into constructors.
Okay, so if we go ahead and say when we initialize our car, we want it to create or instantiate a new engine and assign it to itself. We can do that here. So now if I were to say, immediately after instantiating car, I can say car.initialize. And then I can say car, after I set all of its fields, I can say car.engine.start, then car.engine.go forward, and then I want it to stop. So now if I were to run this, you'll see starting engine, vroom, and stopping engine.
Now we have a pretty big problem, though, and that is that somebody using the car class may forget to call initialize. What happens if you don't call initialize and you want to tell it to go, Nelson? Let's do that with car too.
Well, let's ask, I say we ask everybody else.
Oh, okay, well, let's do it.
All right, everyone, what is the output of this program? And I'll also answer any questions. Did you want to
initialize? Line 50.
He left out an A, but that's okay.
I never spell it right, actually. It's frustrating because certain JavaScript libraries, like Backbone, which one I'm using for BuzzNet, requires a specially made function called initialize. And I always spell it wrong, and then I wonder why my things are getting initialized. That's what you get for using a dynamic language. Okay, Windy Butt UK says fields are members, but what is display called? This is also a member, but it's a method. It's a method member. I'm just scanning the chat for questions because I know people are still putting them there.
They won't stop putting them there until you stop answering them from there. But discussion for another time.
Scroll down just a little bit so that Ray can see the engine stuff.
You mean scroll up?
Or up, yeah, I guess up.
Member, not behavior, then. Well, it is a behavior. Just like this is data or state. Think about the words state and behavior. They're just words. They're English words, but they're not specific things. A field is a specific thing that represents state. A method is a specific thing that represents behavior. So you see how we can use a combination of fields and methods to represent both states and behavior, which, if you recall, is what an object is defined as. So although this isn't an object that we can use at runtime, we can use this definition to create objects we can use at runtime. Okay, so is everybody good with the engine class definition? I'll scroll down now.
Yeah.
Remember, I added the line of code on line 64. That's what we're looking at. And the question is, what's the output of this program? Now, if it's a failure, does anybody know why? And if I know that you know, let me see,
Then don't answer.
Don't answer if you know that I know that you already know this.
Priceless.
But what if they only think that you know that they think that knowing this is known to you?
My brain's stuck in infinite recursion. NATO, let me see. Do you know that I know? No, I don't actually. No engine object yet. Crash. So we got a few exceptions. No engines. Dashi ate her key. Trying to reference something that isn't created yet is null and exception, and so on. Okay, so let's go ahead and run this. Boom. We have our first null reference exception. So this is exciting. I don't think we have...
That's an achievement.
Well, it kind of is, because you are going to be seeing this exception very, 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 very often. It's a very, very common exception that you'll be seeing. And this is the first time that we've actually expressed code that was capable of actually throwing this particular exception. Now, a null reference exception, what that means is you tried to access the members of an object that was not instantiated. Let me show you what I mean. If I hover, everybody kind of remembers the basic debugging stuff, right?
I hope.
Is everybody comfortable with the fact that our debugger has paused execution of the program and we can introspect every variable inside of this IDE right now? Okay. So I'm going to introspect a few of our objects because they're going to be a lot more interesting than just variables or basic variables that we've been using thus far. If I hover over the car object, you'll notice, check this out. I'm hovering over this variable and it's saying it's filled with a console application1.car, which happens to be console application1.car, the type that we have. You'll also notice I have this little plus right here, and I can actually expand this object and see all of the fields inside of it as of right now. And you'll see that we have, well, all the fields that we are expecting represented in data. Now you'll notice the engine field is set to another object, console application1.engine, which is really interesting. Now if I look at this, you'll see the engine is set to null. In fact, the color is set to null, and the name is set to null. But the number of doors in the year are both set to 0.
What?
Do you think it's time, Jason?
For constructors? Or
no,
for a break?
Reference types.
Oh, for yeah, go ahead. No, that's fine.
Well, and a break would be nice, but at least I can explain this.
We're 4 minutes away from a break.
Okay. So what's going on here is this engine object, this engine variable. Sorry, it's not an engine object. This is not an object. This is a field that is nothing. This field contains nothing. It contains null. And null is the textual representation of nothing in the C# programming language. What is going on here is that this object is a complex object. It's a complex value because you'll notice that our classes are fairly complex, and they can even be more complex than this. You can express a lot of different things inside of a class. But by default, the C# compiler will not initialize a field or a variable of a reference type, which I'll explain in a second, to anything but null. And because null means nothing, no behavior can be performed on an object that is null. For example, if I were to say car, my null car equals null, I would say my null car dot display. Guess what I'm going to get? I'm going to get a null reference exception because my null car is 0. Now,
my null car is 0?
Sorry, it's null. My null car is null.
Okay.
Which I kind of C++, blah, blah, blah. Because null is 0 in C++, which I hate, because null shouldn't be integral. It should be just this. Anyway, so we have my null car, and it's empty. It's null. This variable has nothing in it, and we try to access something on it, and it results in an error. That's because my null car is a class, and a class is what's called a reference type. There are a variety of different reference types in the C# programming language. Like interfaces, delegates are both reference types, and there are a variety of other kinds of types which are called value types, such as enumerations or structures. The biggest difference between a reference type and a value type at a conceptual level is that a reference type can be nothing, but a value type must always have a value. So this reference type can be nothing. It can point to nothing. No memory is allocated for this my null car yet. Or sorry, no memory is allocated for the value of my null car. We can fill this variable in with something, some additional memory by doing this. The process of instantiation actually goes out and creates, acquires the memory required to load in all of the data of the type we're instantiating, and it goes out and gets it for us, and then assigns it to whatever variable that we are assigning it to. As a result, you must always instantiate your reference types to something in order to use them. So that's why in this case, this car2.engine.start, that's why it's throwing an exception, because engine is set to nothing. But we want our model to have integrity. We want our representation or approximation of the real world to have certain constraints that it enforces, so that we don't, at a later point in time, get confused with our code. So this is kind of sort of a small discussion about basic design principles here, where one of the invariants, and when I say invariant, I mean one of the rules that a car must always enforce is that it has an engine. A truly instantiated car in our system must have an engine. And the reason I make that distinction is in the real world, a car doesn't necessarily have an engine. You could be taking a car apart, moving the engine from one car to another, and so on and so on. But that process is not being modeled with our application. Our application is very basic. It doesn't have the capability of representing those sorts of behaviors. So as a result, we say that for our representation of the real world, we want our cars to always have an engine. And we want that engine to always be instantiated every time that our car is instantiated. So any guesses about, well, I mean, this word has been thrown around enough, I think, for people to guess as to what we're going to be using in order to force the constraint or the invariant that our car class must always have a newly instantiated engine whenever it's created.
And Steve's right, and with that, we're going to take a break. And when we come back, we'll be talking about constructors. Yay, I agree. Coffee. Okay, so we're taking a quick break, pausing the video.
Nice.
All right, and we're back from break, and we're going to start things off with answering some questions. And first thing we've got that came in was a request to look at Dave's code.
Dave?
Hello? Can you hear me?
Yep.
Are you guys getting feedback?
No. You sound good. Just once you show the screen, we're in good shape.
Okay, I thought I had.
Oh, there it goes.
Oh, there you go.
Do you want my keyboard, mouse?
Yeah. Make it big. There we go. Alrighty, so oh.
Missing parens. In 34.
34.
Yeah, the method has to have.
Yep.
Oh, man.
Throw those in real quick, Dave,
Okay.
and let's see how happy the compiler gets.
And then I have to go 50 is
Yep.
gotta change.
Hey, it looks like a happy compiler to me.
Okay.
Awesome.
Oh my god. Okay.
It's such
Looking at it, it looks exactly the same as you guys. And what the hell? And then, oh well. Okay, that's it.
Okay, cool.
Alrighty.
Now, do you guys give back or do I take it?
Yeah, Nelson's.
Or what?
Yeah, he's grabbing it.
Alrighty, so are there any more questions about this code before we jump into constructors? I do want to point out, though, that those sort of syntax errors, they happen a lot. So
That's
yeah.
a fact. Not even to just beginners. Sometimes it's the dumbest things, and when you find it, you're just like, you gotta be kidding me.
At least it's not like C++. I spent a good few hours the first time I had a small syntax error at the end of one of my header files, but the error was popping up in one unrelated CPP file, and I spent like 2 hours just tracking down a missing semicolon because the error message wasn't. It was like a project with like 50 files in it, and it was like, Okay. Do we need the new keyword? Yes, you do. The new keyword, or the new operator specifically, is what is going to instantiate something. The new keyword always follows a type. And what you are instructing the compiler to do is to instantiate a value, or sorry, instantiate a type and turn it into a value that we can assign to variables. Why would you capitalize public fields? That is just a preference. Public members should be capitalized, period. Now, private fields or private fields should not be capitalized. Private methods should still be capitalized. But we haven't really talked about accessibility yet. Isn't int a type? We don't need to do new int, right? Good question. The reason we don't have to is because the C# compiler has a literal syntax for many of the built-in types. For example, we can still do string name equals bleh. And that's because these double quotes have a special meaning in the C# language in that it represents the literal syntax for an object that's going to be instantiated and assigned to the value bleh. Now, that's because string is a reference type. So instantiation does happen here. It's just hidden from us because the literal syntax allows us to do that for us automatically. Int number equals 10. Number is a value type, and value types aren't technically instantiated, but again, int is a type. It's just the C# compiler has a literal syntax for it. The C# compiler is not going to have a literal syntax for any of our custom types or any of the variety of types in the BCL, such as list. All right, so Can you instantiate the program class? Actually, you can, if you wanted to. I mean, we could do program prog equals new program. We can even do program prog equals new program prog dot. I believe this should work. Yeah, it does actually. Never mind, it doesn't. In C++ it works. You would never actually do this because specifically main is a static member, which we have not talked about yet. But you can instantiate the program type if you wanted to, but program type doesn't actually have anything interesting on it except for this static void main. You never really would want to instantiate the program type. So yeah. Can we also hide the new on custom types? Don't need to show it, yes or no? Hide the new on custom types. Are you referring to doing something like this? Because you can't in C#. In C++, you can do this, which might be what you're referring to, but in C++, this actually has a different meaning than if you were to do a true instantiation. But in C#, it is impossible to not instantiate a reference type. How do you fix the engine start null reference? Okay, well, I guess we're moving on to constructors now, because that's actually what we're about to talk about. But another question, can we make a car fleet class that stores all the cars and create methods inside the car fleet that control methods of the car objects, collision detections, and etc.? Well, yes. Types are a tool that you can use to express a lot of things. Think of it like an empty canvas, and you have a set of drawing tools that you could use to express different images. Types are very similar to that sort of concept, where you can model your types to whatever specification you want. And as you continue to work with types, you will find very common patterns and very common scenarios that you reuse over and over again to accomplish a certain goal using classes. Now, there are a lot of principles and a lot of rules associated with classes that you should follow, but that gets in more into OOD, which we aren't, or object-oriented design, which we are I'm going to be inserting random tidbits of that, but this isn't a design course. This class is about learning the syntax of how to create types. But the answer to that is yes. Remember, though, the goal of a program is to create an approximation of the real world. If the problem you are trying to solve requires the existence of a fleet of cars, then it might be appropriate for your scenario to create a class called car fleet. It wouldn't necessarily be appropriate for other sorts of problems, though. So it's entirely up to you as the programmer to determine it. Alrighty, so what's a constructor? Well, so you'll notice down here how we have a problem. We have this initialize method, which is great because our initialize method goes out and makes sure that our class car, everything is set up right on it. And remember how we established an invariant with this. This isn't anything that we've represented in code yet, but we have said that this car type must always have an engine. And that engine is always going to be instantiated when the car class is instantiated. But we kind of solved that problem in a very ugly way. We created this method called initialize that enforces this invariant, but it's not required that you invoke this method. As you see down here, we do invoke this method on the first instantiation of a car, but on the second one we don't. We immediately jump right into accessing the engine field directly. But remember about these parentheses. These parentheses actually have a meaning. Remember, when you see parentheses, it usually indicates that you're invoking a method. But what method are we invoking? And the answer to that is we're invoking the constructor. The constructor of any type is the method that's going to be invoked automatically when that object is instantiated. Now, if you do not supply a constructor in your type definition, you are not required to supply a constructor in your type definition, but if you do not, the C# compiler will actually generate behind the scenes a default constructor that contains no behavior. So we're going to go ahead and change this code up to where we will redefine the default constructor in such a way that will force a specific amount of code to be executed whenever the car class is instantiated. I'm going to delete lines 34 through 37 because this becomes irrelevant. And I'm going to put in some interesting syntax here. I'm going to say public, again, because we haven't talked about accessibility modifiers yet, but we will. For now, just make everything public. I'll say public car. Now, this is important. The constructor is not going to have, it's going to be a method, but it's not going to have a return type. And not only that, its name is mandated to be the same name as the type we are creating the constructor for. Per definition, a constructor is a method whose name is the same class, the same type we're creating a constructor for, and it has no return value. It's not that we can put in void, because we can't. This would be a error. But what we can do, or it wouldn't be a constructor, what we're forced to do is provide no return type, not even void. Now, because it's a method, it is a method that can accept parameters, but we're not going to worry about parameters now. So our method definition is simply going to be public car, open paren, close paren, followed by what would appear to be a normal method. Now, what I'm going to do is inside of this method, I'm going to say engine equals new engine. I'm going to put the code that instantiates an engine into this constructor method. Finally, on line 50, I'm going to erase this line because the initialize method no longer exists. But you'll see when I run this program, we get the correct output. So let's go ahead and fire up the debugger and watch what happens on line 49. So on line 49, we say car. The next line to be executed is going to be car equals new car. If I hit F11, guess what's going to happen? You see that, guys? The execution jumped from this into this. The new car, the new operator, followed by the car type, followed by these parentheses, actually instantiated a car object and then invoked the constructor. Now that we can follow the constructor, I'll hit F11. I'll hit F11. Now this is interesting. I'm going to hit F11 again, but you'll notice it skipped over this line. And the reason it skipped over this line is the debugger by default isn't going to jump into code that you didn't write. And the default engine constructor, although it exists on the engine class, it's not code that we wrote. It's code that the compiler generated for us. So we don't get to see it. As a result, when we instantiate an engine type and try to step into it, it simply goes to the next line because there's no code to look at that we can actually see in this file. So now if I were to hit F11 again, we jump all the way back to 49. Now, watch this. If I look at this car variable, you'll notice the engine is instantiated. Without having to explicitly instantiate anything after instantiating the car type, we have some behavior that executed immediately after the memory was allocated to hold this data. And the first thing that happened was, or the only thing that happened, was that we assigned our engine field to an instantiated engine type. So now we can continue forward, and then we can jump into car.engine.start, and you'll see start executes. Go forward executes. Stop executes. Display executes. And so on and so on. Does the default constructor set reference types to null and values to 0? Well, kind of, sort of. It actually really doesn't do anything, because you'll notice that what actually happens is there's code that does execute before the constructor executes, which is part of the runtime, and that code in the CLR itself is going to set every value type to 0 or to the equivalent, and every reference type to null, as you can see here. That code executes before the constructor happens. The default constructor literally does nothing. Do you still need line 32? Are you referring to this line? Yeah, with the constructor. Yes, you still need this. See, if I were to remove this line, our engine field is no longer in this type, meaning that we can no longer access an engine variable inside of our instance methods. See, the definition of the data is different than the definition of a method. In C#, and this isn't true for every language, but in C#, you cannot add members to an object after it's been instantiated. Or actually, more specifically, you cannot add members into types after the code has been compiled. Statically typed, meaning the definition of a type never changes. As a result, you'll notice line 35 turns into an error after we remove the field, because engine no longer references a field that we can assign to. So you must have that line there. Does that make sense? Alrighty. Okay, so just thought of something. The engine class only makes sense to use inside the car class. Can we put the engine class inside of the car class? That's a good question. You can. C# supports unlimited nested types if you want to, but I wouldn't in this case. There are situations where I do use nested types, but not as often as you would think. And actually, no. You couldn't. Well, you. If you made a public engine class inside of the car class, you could, but it still doesn't make as much sense as you might think it would, and you're just going to have to trust me on that. All right, any more questions about constructors and how this code works, or anything? guess everybody's good with classes and constructors.
Let's go ahead and move on.
All right. Seeing all the classes in one file is confusing to me. Oh, yeah, actually, you reminded me of a question that I didn't end up asking or answering, and that is, can't different types be in different code files? And the answer is yes. I don't think for this, because we're not using Dropbox yet in this course that students have access to, for Gavin's sanity's sake, make sure to add all your types to the same file, to your program.cs, which will be renamed to your username. In the future classes, we'll have a more robust way of handling multiple files for submissions. But in this case, we're just going to be worrying about a single file. Okay. I presume you could place a constructor in the main method? I don't understand the question. Actually, hold on with that question, because I think talking about staticness, is that a good next one, Jason? Or can I define the engine file in the constructor, or engine field in the constructor? Public engine equals new engine. No, you cannot. Fields or all members, any member of a type must be defined immediately inside of these curly braces that you open after defining the identifier of the type you're creating. So there's no way to actually add a field inside of the constructor. That's impossible. Now, you could add local variables, of course. And the local variable will behave just like it does in main, but it's not going to have any impact on the rest of the type at all.
And just for the record, I'm not dead. I was actually helping Meta behind me with her Visual Studio went wacky for a minute.
Are constructors only created in classes? No. Structures have constructors. Wow. But structure
Let's just keep it focused on classes for now.
Okay. Okay. Ooh, somebody asking about destructors. Because there are destructors in C#. They're not called destructors. They're called finalizers, and they're horrid, horrible things that are terrible and awful, and I hate them. Well, yeah, Segfall points out finalizers are different than destructors, and they are. They're the awful version of destructors, which I'm not even sure why they invented them in C# in the first place. I feel awful about finalizers in C#. SM Jones, thanks for asking. Can you add members to the class program, and would there be a reason to do so in the main class? You can. There's no reason why you can't. I could say public int stuff and public void whoa. I could even throw on a constructor if I wanted, public program. I could say stuff equals 30 and whoa does console write line stuff. And then I could say program prog equals new program prog.whoa and run this. And you see 30 is printed out to the screen. But I would not do this. Generally speaking, my program class will have the main method in it and nothing else. I have not ever really found an appropriate reason to add members to the program class whatsoever. Okay, why is it working public engine? How can you use both with the name engine? Good question. C# compiler is very intelligent, and it identifies the intent of what you want to do in a very in a way that makes a lot of sense when you think about it. It knows this syntax. It knows what a field definition looks like. It looks for your modifiers, and it finds one. Then it looks for your type, it finds another one. Then it looks for your identifier. Now, the only rule about this identifier, other than the normal identifier rules, is that it cannot be the same name as the enclosing type. So you see, car, member names cannot be the same as their enclosing type. But other than that, there are no more rules. And you'll notice something very interesting. If I change the name of this field, or if I delete it, you'll notice on line 35, it highlights to teal. And remember, teal is the color for types. And you'll say, console application 1 is a type, but it's used like a variable. Because right now the C# compiler is saying, well, where do I know engine from? Let's think back. Oh, there's an engine. Let's assume that he's talking about this. Well, wait a sec. He's assigning it to something. That doesn't make any sense. Let's tell him he's stupid. But if I were to add an engine field in, all of a sudden, because this comes into scope, the C# compiler says, where do I know engine from? Oh, the closest thing to me is this field right here. So I'm going to assume that the programmer is talking about this field. Now, I can, of course, override this behavior by fully qualifying the engine type. I could say console application 1.engine, and now it knows that I'm talking about the type version. But we get the same error that we got before. Instead, when we do this, the C# compiler knows, based off the rules of how scoping works and name resolution works, that we're referring to the field engine. Does that make sense?
Can I just interject? Because we've kind of implied this with the way we've dealt with last week's homework, but I don't think we've ever actually stated it. But the program class, the fact that it's called program, is no different to the fact the car class is called car.
Oh yeah.
Actually, I did mention that on the.
Oh, did you?
On the
Sorry,
first
I
week,
must
yeah.
have missed it. It's just I have had people. I just wondered if people were clear on that. It looks by default for a main method to start at, but yeah.
Best name ever.
So perfectly valid in C#. Okay. Can I write engine equals new engine in the field section? The way car has an engine, am I right? Well, that's a good question. That better not be. I don't know what this is, so I'm going to go ahead and change it again. Okay, so I guess we can move on to the topic of field initializers. Because everybody.
Well, I would go ahead and spend a few minutes talking about access modifiers now.
Okay. Well, remember how I said previously that members, they begin with modifiers, and there's a variety of different modifiers that can be used in different contexts. A group of modifiers that you'll see very commonly throughout a C# program are what are called access modifiers. And access modifiers define the scope in which this member can be accessed. Now, look at okay, so there's a few different access modifiers we can use. We can use public, protected, internal, or private. Or protected internal, but that's different. The ones we're going to be looking at are going to be public and private. Those are going to be the two main ones that you're going to be using for now. Now, public, not surprisingly, means that everybody can access this member. Everybody can invoke this member. Or in the case of a field, everybody can modify or read from this member. But oftentimes, that's not very appropriate. Remember the word invariant that I mentioned before? When I said that a type really should enforce rules about the data it contains, the state that it contains, and it should be responsible for understanding how that state is in a valid, how that state's in a valid state, and enforcing that the state is in a valid state at all times. Well, we can't really do it do that when all of these members are public? Because we're not hiding these members from anybody. Anybody can jump in and modify our name or our year or number of doors or our color or our engine. I mean, you saw that I instantiated this type right here and assigned it to a variable. And you notice that, remember that the constructor is invoked? What happens if I do this? Now what do you think is going to happen? Right. Because we have a null reference. We have successfully broken the invariant of our type and basically underscored the stupidity of the person who architected this type. So this should not be possible. A type should not allow itself to turn into an invalid state. And if somebody attempts to turn it into an invalid state, what should we do? Because remember, that's a bug. And what do we do with bugs?
Set them free.
We don't eat them. We throw them. We throw the bugs in the form of exceptions. And so we would want an exception to be thrown if we ever ask the card to do something that it was not capable of doing, because that means whoever is consuming this type clearly has no idea how to use it and therefore needs to be reminded in a very forceful way. So how do we accomplish this? How do we make it so the cars can still have an engine, but the engine becomes private? The engine becomes inaccessible, at least as far as setting the engine goes. Well, the first step is to make it private. So if I change this accessibility the accessibility modifier to private instead of public, or in fact, if I leave the accessibility modifier off because it defaults to private, you'll notice something very interesting. Two things, in fact. The first thing is that on line 37, this code still executes properly. It still instantiates a new engine, so that's awesome. Because although this field is now private, although the accessibility modifiers specify that this field cannot be used by anybody outside of this type, we can still use it from inside this type. And that's what you see here on line 37. But you'll notice the second thing is lines 51, 58 through 60, and 65, we have errors. And so we basically took one step forward on line 51 and then two steps back on line 58 through 60 and 65. You'll notice we can no longer set the engine to null. We can no longer reach into the car and pull its engine out while it's in the middle of driving. That's now impossible for us to do. And if you look at the error, it'll actually refer to the fact that it's inaccessible due to its protection level, which is another way of saying the accessibility modifiers on that field disallow it from being accessed from anybody outside of the type itself. Okay. Yeah, somebody said read-only. Read-only is different. It does different things and it's used for different stuff. And I don't know if we're even going to be talking about read-only.
No, not today.
So now we have a problem. It's great that we can no longer yank the engine out of the car, but we can no longer actually start the engine anymore. Or go forward or stop. Now, I do want to quickly point out another tidbit of design right here. As far as object-oriented design goes, we oftentimes will want our objects to mediate the communication or the relationships between other objects themselves. We would want the car to mediate the communication between the outside world and the engine itself. So oftentimes we might put methods on the car such as public void start, public void stop, and public void go forward. Now, why would we want to do this? Well, I'll go ahead and complete these methods. Okay, so I've just changed these methods. I've added them to the car class, and I've modified the invocation to invoke the methods on the car class instead of the engine. Now, the next thing I'm going to do is I'm going to rename this field. I guess we can finally take a quick moment and talk about private fields. Private fields, there are two ways that are the most popular. There are two popular ways of naming these. There's what I like. I prefer an underscore followed by a camel case. Alternatively, there is just camel case. Now, Jason and I both disagree on this, but I've also seen a variety of open source projects, some that use this syntax and some that use that syntax.
Again, why do we disagree?
Because I feel that this makes the code cleaner.
No, we disagree because I'm following the specification. That's all.
Well, that's what I just said. I think this is cleaner, but you're following the specification. So you could argue either way for that, but we won't argue here about it.
Of course not.
But because I'm typing, I don't want to get tripped up. I'm going to go use the underscore because I don't want. If I'm typing quickly, that's what I'm going to spit out. Okay, so we've successfully renamed this field properly, or at least one variety of what could be considered proper. Either way, Jason and I will both agree that this is much preferable to having the field named with a uppercase character at the beginning.
Yes.
Which is bad, unless it's public. But public, we'll get into that. So now we have a private field engine. We've successfully encapsulated an engine into our class, and we've hidden it from the rest of the world. And if we go ahead and run this program, we get the same behavior. Starting engine, vroom, stopping engine, giving its name, its year, number of doors, blah, blah, blah. So that's really cool. But I just want to point out that this is a valid way to express this logic. And the reason is, and again, this depends on what your model is. There are so many ways to express a problem in the real world using code. And even if your problem differs slightly from another problem, your code might change drastically, the way you organize your types, what things you put in them, and how you make them behave. But I could really quickly just give a case for why this might be appropriate. And the reason is conceptually, starting a car might require more logic than simply starting the engine. There's a bunch of things that the car might want to do. Furthermore, the car might want to enforce a particular invariant. For example, when you call the start method, the car might want to enforce the invariant that the key is in the ignition. Now, the engine has no concept, or in this model, the engine would have no concept of what a key is or whether or not a key is in the ignition. By giving the responsibility of starting the car to our car class, we have successfully enabled or created a situation where the car is the arbiter as to whether or not any of these operations are valid, and it has the ability to use any of the fields that it has accessible to it. I want to stress that point, that the engine is only responsible for what the engine is responsible for, which is being an engine. The car is responsible for quite a few more different things, but what it's going to do is it's going to delegate the responsibility of certain things to other objects. I just want to point out that you can create a variety of different objects in your program, and you will undoubtedly end up creating a variety of different types in your program, and that generally speaking, they'll have very specific responsibilities, and you'll really want to think about the way that your code interacts with those types. In this case, like I said, we've funneled the responsibility of starting the car into the car type itself, meaning the car is the responsibility of starting itself. It's still going to delegate to the engine at some point. It's still going to say engine.start because the car really doesn't care what the engine needs to start itself, but the car might care that the key is in the ignition or the doors are closed. Same thing with stop. the car might care about that, those sort of things. Same thing with go forward. I mean, go forward, we have the engine.go forward, but what if we want to calculate the drag caused by the foot on the brake or the e-brake or something like that? We could do so in a more general object and leave the specific operations to a more specific object. Okay. Emergency brakes. Wait a sec. UK people don't have e-brakes?
No.
Huh. That's terrifying. I was parked in Seattle a few days ago, and I was parked on this hill, and that scared me just to leave my car there, but I couldn't imagine leaving it there.
Oh, a handbrake. Parking brake.
Oh. One of those. Well, mine's not in the hand. It's a foot thing that I push down. But my car is automatic, so there you go. Alrighty, so yeah, this is one way to. Do people sort of understand why the accessibility is important? I know I did. Like I said, I did really want to sort of describe some bits of OOD during this class. I don't want to make this an OOD class, but the thing is it's a catch-22. You need to understand the syntax to understand the design. You need to understand the design if you're going to use the syntax. So I did want to point out why this is an appropriate solution in certain cases. There's an alternative solution, which we'll be talking about shortly. But at least does everybody understand the concept of what we've done here?
You said, of course, they get made private by default, the fields, but classes don't.
Classes are internal by default.
Right.
Alrighty. Okay. Should or can the constructor be private? Good question. It can be. Can anybody guess what's going to happen now? I want to guess. I've changed the constructor from being public to private. Ooh, we did get an interesting one. The default one will run. We got a variety of you can't instantiate it, error when you make an object, inaccessible. Program can no longer see car, another interesting one I'll talk about. Okay. The answer is we cannot instantiate it. You'll notice we get an error. It'll say console application 1.car.car is inaccessible due to protection level. Now, one person asked if car is no longer visible to the program class, and the answer is no. Car is still visible because the way type accessibility works means that car is still visible to this type. The constructor, however, is not. There's a distinction. The constructor is not visible, but the object, the type itself, is visible. And you'll notice that in the error message, it specifically says console application 1.car.car. So this is the constructor inside this type. Another person asked, would the default constructor run? That's another good question. The default constructor is not created if we, in a class, this isn't true for structures, but for a class, the default constructor is not generated if there is any other constructor, period, even if it's private. So why would you want to do this? There is two reasons, but we are probably not going to go over them.
No, not right now.
But I just want to point out that you can, and the behavior is defined. So the constructor or accessibility modifiers on constructors work as you would expect them to. There are reasons why you might want to do this, but we're not going to cover them right now. For now, just leave your constructors public. Okay. How do you feel about properties, Jason?
I think it's about time for properties.
All right. So remember how we started off with this engine being a public field, but then we decided that we wanted to disallow the concept of somebody yanking the engine out of a car that's been created. So we made it private, but that caused us not to be able to access any of the engine's members. So we came up with this solution where we give the responsibility of interfacing with the engine to the car. And I talked for a few minutes why this might be appropriate, but in certain cases it isn't appropriate. It really has to, the situations where I would do this over what I'm about to show are fairly complicated. We would need a more fleshed out use case for me to explain the differences. But let me just show an alternate implementation of this that might be a bit easier to implement. It is a little bit less flexible, but again, it's by no means an inappropriate solution for certain problems. That's the concept of properties. So what we want with this property, or specifically what we want with this engine field, we do not want to be able to set this engine field to anything. But we do want to access it. We want to say car.engine.start, car.engine.goforward, car.engine.stop, and car.engine.start. We want to be able to do this, but we don't want to be able to do this. We have one option that people will eventually, if I were to ask people to use the existing things we've discussed up until this point to come up with a possible solution, we do have a possible solution. We could say public engine get engine. We can say return engine. And so now we can simply say car.getEngine equals null, which doesn't work like what we want, but we can say car.engine.start, car.engine.goforward, car.getEngine.stop, and car.getEngine.start. So this gives us the behavior we want. We can say car.getEngine perform operations on the engine, but we can't assign it to anything because it's a method, and you can't assign things to methods. I want to point out really quickly that the poor people in C++ land are forced to do this when they want to perform this operation. But C# and actually no, Java doesn't have properties either. I just remembered. So yeah, people who are writing in C++ or Java are stuck with making methods that return fields for certain cases. But the C# developers thought that they could do better than that. And what they came up with, or what they borrowed from another language, I'm pretty sure it existed in another language before, is the concept of properties. And what a property is it's a special field, but it acts like a field, it looks like a field, it feels like a field. But it's really a method or two methods. The way we define a property is fairly straightforward. We give it an access modifier because a property is a member, so we can give it an access modifier. In this case, we want a property to be public, just like how we made this method public, because we want to be able to get the engine, we just don't want to be able to set it. So we start off with our access modifier public, and then we give it a type. That's very important. We have to give our property a type. After we give our property a type, we give it an identifier. Okay, so as of right now, this looks like a public field. In fact, if I were to add a semicolon right there, that is a public field. But let's go ahead and blow everybody's mind. I've opened curlies on a field. Come on, is anybody's mind blown, or does everybody already know what
My
this
mind
is?
is blown.
Now, watch this. What we've done here is we made something that looks like a field, and in fact, it behaves a lot like a field. It can behave a lot like a field, but instead of this being direct data that we can access on this type, instead we can do one of two things. We can get from it, or we can set it. Now, in this example, I've only defined a getter, This is what that's called, a getter. When we open up our property block, this is not a method right now. This block is not a method. This block only allows for two things. It allows for the get keyword followed by a block, or the set keyword followed by a block. Now the get keyword, when you specify this inside of a property, what happens is we get a method like this. In fact, I think it turns into something like that or something. The C# compiler does that or whatever. But the point is that we make a method that has this signature. When we specify the get keyword inside of a property that has the type of what we want to return. Because this is actually a method, this is a true method, we can do methody things inside of it.
Methody things?
And one of the methody things we can do is execute code. Furthermore, we can actually return a value, or in fact, we're forced to, because this get keyword actually does define a method. The method signature looks like this. This turns into a method that looks like this. The method is hidden. Its name isn't actually getEngine. It's like some underscores and stuff or whatever. But the point is that the get keyword is going to go ahead and automatically open up a nice little method for us. And this method allows us to execute code and return a value of the type of the property. Where is the set? I'm not going to be showing sets just yet. We'll talk about sets in a moment. Remember, the reason we're making a property here is because we want to be able to get the engine, but we don't want to be able to set it. So we're not going to be adding a setter into this property, which is perfectly valid in C#. Anyone else think that well-named methods are more easily readable than properties? It depends. There's a lot of scenarios where people use properties religiously, and I would much rather see methods, specifically with performing operations. Very, very few of my properties will have public setters. I do prefer methods in that case. Some people don't. It's a style thing, I guess. Generally, when I think of a property, I think of something that's going to execute relatively quickly. So I prefer to put as little logic as I can inside of them, but I still will use them quite often when there's a situation where they're appropriate, which is often. Okay, can we still set engine from within car even if you don't put in the setter? Good question. Answer is no. We cannot do engine equals new engine. This is impossible. And the reason why this is impossible is that there is no setter. The error specifically says property or indexer console application 1.car.engine cannot be assigned to. It is read-only. This property is read-only, so we cannot set it from even within car. But what we can do is set the field engine. But the field engine, remember, is private. Nobody else can access this field engine. But what we do here is we expose the field engine with a property that looks as if it were a field and behaves as if it were a field. Okay. So let's go ahead and refactor our code up a little bit. I'm going to go ahead and delete this getEngine method and replace it with car.engine. So car, and if we look at the IntelliSense, we'll see this engine. Notice the icon here. This is the icon for a property. I'm sure you're all familiar right now with the method icon and with the field icon because it's similar to the local variable icon. But this is a property. And we can access it just as if it was a field, but you'll notice something interesting. I'm going to go ahead and make this more obvious. Look at this. every time we access this engine property, we are getting code executed, which is interesting. So how is everybody feeling so far about properties?
Have them write something.
Mike S. Write something?
Have them write something. You haven't had them do anything in a while now.
Oh, how mean can I be? I have a good one in mind. Okay. It's actually going to do two things, one of which I haven't explicitly defined yet, but it should be inferable based off past experience. Okay. Your goal is to create a car class that has the same data, or state data, or obviously state, as what is defined below. However, turn each field, or make each field private, and create a read-only property that allows get access to each one. Finally, create a constructor. I'm going to write CTOR. I do that very commonly without thinking. That is a very, very common shorthand for the word constructor. So just in this case, I'll add constructor right here. But most of the time, I will just write CTOR. Create a CTOR that accepts name, year, number of doors, and color, and assigns each param to the correct field. Alrighty.
That's not how you spell field.
Oh, yes. Delete the parameterless CTOR.
You can switch the I and E at any time. And you can do that in the first paragraph as well. It's just if you feel up to it.
I don't know. There's this guy who, it's a long story. I'll tell you when the video's stopped.
Okay, well, I'm going to go ahead and hit pause so that everybody can do this. Okay, there's one more thing Nelson wants to add in.
In main, create two cars with different arguments passed into the CTOR and have them be displayed by using the display method. Okay, that's it.
Okay. All right, we have now resumed, and NATO said please don't switch over to his screen.
Well, I mean, we could do it off video if he's more comfortable with that.
He's just not comfortable, period. You know, you can just share out just the Visual Studio app and keep yourself muted.
You didn't change your Visual Studio theme, did you?
Oh,
it's horrendously enterprising.
All right. Well, did you want to go ahead and demonstrate how this should have been done?
Okay. So we're going to go ahead and we're going to make all of these. We're going to start with making all of these public fields to be private. So I'm going to do a little block select and say private. Now all these fields are private. If I were to compile now, we'll get a bunch of errors saying, car.name is inaccessible, blah, blah, blah. But that's actually what we want. What I'm going to go ahead and do now is I'm going to rename all of these to be the appropriate private field names. So I'm going to say underscore name, underscore year, underscore number of doors, and underscore color. And I'm going to get rid of this white space right here because we don't need that separation anymore because they're all private fields. The next thing I'm going to do is I'm going to create public properties that allow us to access each one of these private fields in a way that we can't edit the values of them. So let's go ahead and do that. Let's say public string name get return underscore name. Public string year get return year. I really want my resharper right now. Public derp. Public int number of doors get return number of doors. Public string color get return color. Why do you need to express the type for the engine? The reason we do is because the type of the property is going to be, because properties are kind of, they sort of behave like variables. They're not really variables, but they behave like them. The goal of a property is to sort of make something that looks like a variable but is really a method. And we need to express the type of that variable that it's going to be. Because remember, C# is a statically typed language. We're forced to be consistent with the types that we return. So they must be the correct types of whatever we're returning. Now, in this case, we are returning a private field that is of type engine. So therefore, the property must be of type engine. The same goes for name, where name is a string. Therefore, the property name must be a string. Year, number of doors, and color. These are all types. All of these are types. This one is a custom type that we defined. These are all built-in types that we can use.
I always think of those as being the return type.
Yes. They're going to be the return type of the method that gets generated. Which is more correct to say it's the type of the variable, because again, properties aren't variables. They're really just wrappers over methods. Okay. So we've accomplished the first step, but remember, we have another thing. We want to create a CTOR that accepts the name, year, and number of doors and color and assigns each of the parameters to the correct field. Delete the parameterless CTOR. So I'm going to go ahead and delete the parameterless one and create a new one. I'm going to say public car. And inside of car, remember that this is a method. It is a special method called the constructor, but it is a method nonetheless, which means it does have a parameter list. So we can specify parameters here. We'll start with name, year, number of doors, and color. And we can turn straight around and simply say, well, name equals name, year equals year, number of doors equals number of doors, color equals color. Dunn says you can have more than one CTOR, and the answer is yes, we can, but I don't want a default CTOR. I want every single car to have a name, a year, number of doors, and a color. And in addition, I could very well do some validation here. I could say if string.is null or whitespace name, throw new argument exception, and then say name. Or, sorry, name cannot be empty, comma, name. I can do other things like if number of doors does not equal 2 and number of doors does not equal 4, I could say throw new argument exception. What kind of car is this?
One with a boot.
Number of doors. And so on and so on. This is why I don't want a default CTOR or a parameterless CTOR, because I really want to enforce that these values are correct before I actually allow the car class to be instantiated. by not providing a parameterless CTOR, we're forcing them to set all these properties to valid things when the object is instantiated, thus enforcing the invariance that we have defined for this type. So the last thing I need to do down here is fix up my main method. You'll see in main create two cars with different arguments passed into the CTOR and have them be displayed by using the display method. So I can go ahead and nuke both these guys, and I'll start from scratch. I'll go ahead and say car1 equals new car. But notice this. Check that out. Our constructor has parameters. We cannot do that anymore because there's only one constructor, and that constructor forces us to pass in and supply these pieces of state, which is very important. So let's go ahead and call this one Dashy again. Give it a year 2010. Give it 4 doors and say it's light blue. A rainbow main. So we have our first car, and we can go ahead and display it. We can say car1.display. We can create another car if we wanted to. We can say car2 equals new car stuff. Give it a year of 1994, or how about my car? My car doesn't have a name. No name. 1999. Number of doors 4. Color dark green. And I can say car2.display.
Now you can say well, not car1, but you could do car1 equals new car again.
Yeah, I can repeatedly reinstantiate these types over and over again. In this case, I wanted to alias these out to separate variables, though. But like what Gav said is correct. I could reinstantiate my car1 to be Dashy2 for season 2. So, and so on. But, okay, so now we have our two cars that are being displayed. If we were to run this program, get the proper result. So that's really cool. Our code really cleaned up. And not only that, we actually did a lot of cool design stuff here. Except for we've also introduced a bug, which the C# compiler was keen enough to warn us about. ReSharper will do the same thing, but you'll notice the engine is actually never assigned to anymore, which means that if I were to do car1.engine.start and I were to try to run this, I'll get a null reference exception. We can fix that by simply instantiating the engine inside of our constructor. Okay. So this is really cool. We have this really nice type class now, and in so much that you can't do anything to it without explicitly asking it to perform an operation. We can no longer arbitrarily edit the behavior of this object. And more importantly, we can instantiate as many of these objects as we want. So things become very clean. Is there a convention about where to place private, public, property, and methods in a class? There are many conventions. The convention I follow is, and the most common convention that I see, is it goes fields first, properties next, CTORs after that, public methods after that, and then private methods following. Is there anything you want to say about that, Jason? Just if you have a different sort of opinion about that. He's probably helping meta. Alrighty, so yeah, that's what I do. It's a very common thing.
I'm sorry, I was just sitting here saying that I completely agree. I had the hiccups again, so I had to mute.
Oh, do you keep like INumerals separate?
INumerables?
Like, well, say if you've got a class with lots of lists of things.
I'll generally group related types together. In this case, I do. I would generally, if I was writing this out, I would do something like this. So you notice how I group the strings and the integers?
Yeah.
I'll commonly do that. Line 40. Oh, yes. Well, it's actually, I just have to recompile. and that error goes away, or that warning goes away. Okay, is everybody good with what we have here? Like I said, we have this really awesome class. We've defined a lot of cool stuff, but in a very abstract sense, in that we've created this powerful car class that enforces some very important constraints and has some really awesome functionality that we would want to use often. But does everybody have any questions so far about what we've been doing? At least starting with using an object as just a bag of properties, or specifically a bag of fields, we've now actually turned this into a decent looking class, where this class must be instantiated with a valid state, and we cannot change that state after the class has been instantiated, unless we were to add additional members here that allow us to, which is going to be next. So is everybody good at this point? Any more questions? Okay. I did this without getters. Is that bad? Not sure that I understand how you could accomplish this without getters. Did you leave the fields as public? Wait, what? Oh, do you mean that you just didn't have any of these? Well, it's not. In this case, it's not bad. But if we wanted to, for example,
what if it was the program that was in that had the display method?
Right. What if we wanted to do car1 dot? What if we wanted to print out the name specifically? You can't do this unless you have someone access this property without creating the property. Whether or not you expose a field as a property is a design decision that's going to have to make sense for your particular problem that you're solving. Actually, you know what? I want to do something cool right now.
Magic trick?
Well, no, I'll say that magic trick after this. I want to show setters, and then I want to show something else.
Yeah, autos.
Well, fine. I want to show setters, then autos, then I want to show something else. Okay. So setters. Now, I'm going to be honest here. I do not use public setters very often. But they are used, and there's no thing I could say about them that would, say that they're not bad at all. I just don't find myself needing to use them very often, but you need to be aware of their existence, and you will be using them quite often when starting out. Conceptually, I prefer methods that actually alter data or alter state inside of an object. I prefer those to be methods, and because oftentimes you might want to change a single property, but sometimes it makes sense that you want to change more than one at a time. And I prefer those to be methods. But in this case, let's go ahead and show you guys what a setter would look like in these and how we can use setters to continuously enforce our invariants. So I'm getting an exception on line 61. Is the number of doors you passed in, is that either 2 or 4? Because this invariant enforces the fact that the number of doors you try to instantiate your car with must be 2 or 4. And if it is 2 or 4, another possibility is you use the logical OR operator instead of the logical AND operator.
So do you not count the trunk as a door then?
Do I what?
Well, we count the boot doors. We talk about 3 doors and 5 doors in this country.
What's a 5th door?
The boot.
Trunk?
Yeah.
Huh. You guys are
Do
weird.
you count the glove compartment as well? I mean, it is a door after all.
Well, no, it's when it's like he says, when it's a hatchback. If it's a separate thing, but otherwise it's just a door into the back, isn't it? If you can get at the back seats from it. We need to be doing net localization.
I thought you put -3 at first. Wait, whoa.
Okay, so is your exception, have you looked at your instantiation and made sure that the number of doors that you're assigning is either 4 or 2?
And Mikey's talking with you just in case you weren't sure. And we're looking over the questions panel. Or wait, no, back over Buzznet. He said 2 doors.
And you're still getting an exception. Do you mind if we switch over to your screen?
I'm going to try and beat my speed record.
Hello?
Mike? He said, sure, go ahead.
Okay. And he is Michael...
S? Yeah, well, you see which one it is.
There it is. Okay.
Svegot.
I'm bad with making words happen.
Or Schweigor.
Schweigor.
Even.
Alrighty, so yeah, if you scroll up, so if you run this web, if you hit run.
Or if you could. There we go.
Missing underscore.
Yeah, look closely on line 62. You'll notice that your the parameters you passed in are the same names as the fields. Now, remember that those are 2 distinct pieces of data. The parameters that you pass in on line 62 are not going to be the same things as your field, and they shouldn't be named the same way as your fields.
Nice. Yep. All right, you switching back over, Nelson?
Actually, as Segful pointed out, he's actually reversed the naming convention there.
Yeah. If you notice on my line 52, I don't have underscores on my parameters, but then on lines 40 through 44, I use underscores for my fields. Actually, Microsoft for parameters will not want you to place underscores. See, if you're sticking with the Microsoft convention, I'm going to go ahead and really quickly show you guys what you need to do to make this work.
Loads of thises.
Yeah. I'm going to switch over to using no underscores for my fields. The proper way to do this, you'll notice, is that on line 64, well, they're errors. Okay, on line 64 through 69, 64 through 67, I am assigning things to themselves. If I were to run this program, look at this. Car name blank, year 0, number of doors 0, color blank.
The most ultimate car.
Yeah. So you'll notice that these parameter names are overlapping and replacing the meaning inside this method with what these fields are. The only way to combat this, I would not rename the parameter. That will be confusing. Very, very, very confusing. The only way to combat this is when you're talking about fields, when you have parameters that overlap in the fields, the only way to fix it is by doing this dot. Now, if I were to run this program, we get the proper result. So if you want to follow with this naming convention, then you have really no other alternative than to use the this dot syntax here. And what the this dot syntax here does is it specifically scopes these variables to the object that we're working in itself. This is a special object that will always reference itself. You'll notice that if we hover over the this keyword inside of car, it's going to be class console application 1.car. And I do agree with Segfault right there. Forcing yourself to come up with new names just to make the syntax work it'll be confusing, because this way it's explicit. Same thing with this way. If I was reading through the code, I would know instantly that you're talking about fields instead of parameters. The same is true for this. If you're following this syntax, I know instantly that you're talking about fields. There's no ambiguity. Meaning you don't have to force yourself to come up with different names. And Microsoft, in fact, will say in their naming specification that making the parameters different names by adding superficial prefixes to them isn't correct.
Like underscores.
Yeah, well, that's the parameters.
But yeah, if I saw that, I would just get confused. I mean, words. Okay. Ooh, Barry did actually point out something important. We didn't cover throw new argument exception last week because we actually covered this in the Thursday class, and I kind of forgot. Basically, what we're doing here is we're throwing a new exception, meaning that we are causing an exception to happen. If line 56 ever executes, execution is immediately going to halt and behave like it did when we int.parsed an invalid string, where this new exception is going to bubble up the call stack and be optionally tried and caught by a try and catch statement, or break the program entirely and launch into the debugger. Okay, so setters, I guess. Let's talk about setters. So we don't want a setter for engine, because what a setter does is it allows us to do this. Let's say we want to change the name of my no-named car. Let's say one day I decide to call my car stuff. You'll notice I get an error. It says property or indexer console application 1.car.name cannot be assigned to its read-only. But we want to make the syntax valid. We want this to work. The way to do this is to provide a setter for our property. So let's go ahead and take a look at what that looks like. Not surprisingly, inside of these parentheses, inside of these curlies that are immediately opened and closed after the definition of the property, what we want to do is give the keyword set. And set defines another method that's going to go ahead and be a setter, essentially. It's going to be the analog for this. So you remember how we had, let's say we have public string get name. That returns a name. And then we have public void set name, which says string name equals name. This is the getter, this is the setter. Now, fortunately for us, the C# language has the concept of a setter built into properties. So what we can do is we can go ahead and define a setter by using the set keyword and opening up a block. This will define a method with a signature similar to this. Now, here's the thing about the setter. We are not obligated to do anything with it, meaning the code that you see right here is valid. So, okay, go ahead. Does anybody need a second to look at that? Because I'm about to ask a question, but I can't keep both things on the same screen at once. Does anybody want a second to look at that code?
I was about to ask a question, but it might give away the answer to the question that you're about to ask.
Okay.
depending on what it is.
Are people even alive in BuzzNet?
Yeah.
We'll type something over in BuzzNet. There we go. Hello. Okay, good.
Okay, so I guess nobody needs a second to look at this code anymore. Okay, I saw everyone. That's good. Thought it died for a second. What is the output of lines 94 through 97? Now, you don't need to do the entire display method, but just the general idea of what I'm probably going to be asking. And segfault, you're not allowed to answer. Okay, we get a no name, then stuff instead. No name for both. Oh, did I put everybody to sleep or something?
Huh, what? What'd you say?
Usually when I ask a question, like there's like
You know, a bunch of answers.
Yeah, well, we got two. Okay, I'm going to go ahead and hit F5. The output does not change.
Can I ask my question now?
Sure.
But surely that setter with the open and closing curlies, all that'll do is eat the error.
Well,
and nothing will get set.
Yeah. It doesn't do anything.
Yes, I know. The question I was about to ask before you asked everybody whether it did anything or not.
Yep. So let's fill it with something. Our setter, we want to set name to something. Here's the problem. We need a way to actually reference the value that the person passed in on the right side of the equals. So you'll notice down here we say car2.name equals stuff. We need to access this because this method will, the method or the properties setter specifically will be invoked. But currently, how do we get the value we try to assign it to inside of our setter? Well, the C# language has a very nice little keyword to use in this sort of scenario. It's going to be called value. Notice the keyword because it turns blue. Value is going to be whatever value the person tried to assign it to. So if I were to run this program now, you'll see the output that you might have expected before, where the name of the car actually does change because we put logic into this property here on line 9 that's invoked on line 96, and we actually had it do something. Okay, here's a problem. Remember my invariant I defined right here on line 61? I said if the string is null or white space, throw an argument exception because we don't want to deal with cards without names. Well, what do you guys think the output of this is going to be? I run this. We broke it. Our car class no longer is valid. Our car object's no longer valid in the context of our model that we've decided that we were going to create. So that's bad. But here's the thing: we can put as much logic as we want in the setter. It's not a good idea to do a whole lot of logic, particularly operations that might take a second. Like don't put file I/O or network I/O or any sort of things in there in the property. Simply because, generally speaking, when a programmer accesses a property, they expect an immediate result. A method kind of has more weight to it, where a person might expect something to take a little bit longer. Property should be very fast. But something that's perfectly acceptable to put into properties is validation. Meaning I can go ahead and copy this code right here, or I could just write it out myself. I can say if string.is null or white space, and then pass in value, which we can reference as many times as we want in the setter, then throw a new argument null exception, which actually is probably more appropriate exception than an argument exception. So now if I run this program, what do you guys think the result's going to be here on line 104?
Do you want to take out your failing, the method that you just replaced? By the way.
Method?
Or rather, the if check. If is null or white space.
No, I wanted to keep this in to enforce that constraint.
No, the old one. On line 69.
Oh, I could do that. I could delete this right here on line 69 through 72, but then instead of setting the field name, I have to set the property name. So now we did reduce the amount of code by a little bit by assigning it the property name to the value name instead of the field name. So if I go ahead and run this, we'll get a nice little exception. Value cannot be null. So now we've successfully managed to enforce the fact that our name cannot be blank, which will include the constructor, because now the constructor uses the property that has the validation. If I tried to do an empty string right there, I'll also get that exception. So it's very cool stuff. And finally, we can now successfully rename our cars while still enforcing our invariants.
Excellent.
Chris, so it's automatically knows to call the set. I would assume you would have it call it like a method. That's a good point. Behind the scenes, the setter is a method and the getter is a method. That's behind the scenes. The property syntax in C# is basically just a nice little shorthand for invoking special types of methods. So on line 99, we are actually invoking a method. In fact, if I were to set a breakpoint here and hit F11, and then the debugger will say, you just stepped into a property. And I say, well, no, I don't want to be notified. Oh,
Did you actually want to be notified, by the way?
no, I want it to go away. No, I do not want to step over properties and operators. Okay, so now if I hit F5 and hit F11, you'll see we jump into this method. So behind the scenes, this is a method that's being invoked. It just doesn't look like a method because it's a nice little bit of syntax that we can get in the C# language. So you see that if I hover over the value variable, you'll see that it contains the value that we passed in. Okay, is everybody good with setters? So in essence, you make one thing extra for every variable. One name variable and one name get setter. Yes, it's exactly what we do for a lot of reasons. Fields should never be public. There are some public fields in the .NET framework, but some of them I don't even disagree with them being fields, but in general, fields should never, ever be public. Because
unless you're using Unity.
Even in Unity, well, if you want to use the inspector, then
yeah.
You have to use fields. So getter and setter are actually methods. Yep. Behind the scenes, they're methods. The CLR has no concept of properties. That's a C# specific thing. And a VB.NET and F# specific thing.
But Nelson, that still seems like an awful lot of typing.
Yes. Gavin. It is an awful lot of typing.
If only there was a way to type less and get the same result.
Yep. What I'm going to do is I'm going to delete all of this. Well,
Yeah, he's got a point. Ditch the validation.
right, which we're going to fix by using a method setter. Alrighty. So we're going to nuke this code, I guess, because we don't need this code anymore. Because, well, you know what I'm going to do? I'm going to open up a new Visual Studio instance.
Did I just enter a time warp then?
Time warp?
The same 10 seconds happened over and again.
See, I got distracted from Segfall's comment, and so I got, yeah, basically it did. Okay, so I am now going to delete all of this code, and I have it back in another Visual Studio project to reference in a moment here. Here's the problem. We no longer have any fields or properties. We want fields and properties. Let's go ahead and redefine our fields and properties. Let's use some special syntax. And the code does the exact same thing, minus the validation, of course. All right, I guess NATO's like, what just happened? Well, I turned this code into this code. These are called auto properties. Auto properties are, well, they're automatic properties. An auto property looks like this. You start with your access modifiers just like before. You start with then your type just like before, then your name just like before. So standard stuff. Then we open up the curlies and do something fun. What we're doing here is we're simply saying get semicolon and set semicolon. What this does is the C# compiler actually goes out and creates a corresponding field for each one of these automatic properties and generates both their getter and their setter to modify and retrieve the value of that field for us. Get very, very, very useful or used to this syntax. Any questions so far? And Maxim,
I always call him Masms.
Masmus. I'll be getting to that in a second. Alrighty. Any questions about auto properties so far? Yeah, David, we're going to be doing that in a second here. That's the next thing. But I just want to make sure that the basic form of automatic properties. Now, I do want to point one thing out right here. One very, very, very important thing. You cannot have only one of these. You cannot have just a getter and you cannot have just a setter. Now, you can with normal properties, but you cannot with automatic properties. Must have both a getter and a setter. That's the big rule about auto properties. Don't you lose your ability to verify stuff in your properties? You do, which is probably actually a concrete reason why I use methods to set things rather than properties. And we'll get to that in a second too, as far as how we can make this work with validation. So yeah, automatic properties, great stuff. We have a problem. We are now back to square one. This is completely valid because all of these getters and setters are public. Now remember, getters and setters are methods, and methods can have accessibility modifiers attached to them. We can override the accessibility modifiers attached to the methods that are generated for the getter or the setter. And we do that very simply by saying private set. So the getter method is public, the setter method is private. As a result, if I were to try to build this, we now get an error saying that property or indexer console application 1 car engine cannot be used in this context because the set accessor is inaccessible. Very cool stuff. So let's go ahead and make everything private, because the problem with auto properties is we could not enforce invariance with them. But now how do we change the name? Because you notice this now is red, which is good, but this isn't. And if I were to make this property public, or this property setter public, then I would be able to set it to an empty string, which is something I don't want to be possible with this class. So here's what I'm going to do. I'm going to make a method called update name, string name. I'm going to say if string is null or white space name, throw new argument, null exception, and sure. If that works, set name to name. We're allowed to do this inside of the class because the setter still does exist. It's just private. It doesn't have it has the accessibility of it's local. The accessibility is local to this class. So now just to reuse this method, I'm going to say, instead of name equals name, I'm going to say update name, name. And now down here, instead of saying car2.name equals and things, I say car2.update name and things. And we get the result that we want. Generally speaking, in more complex examples where I use what are called value objects, or should not be confused with value types, and when I'm writing real components, I'll often do this because oftentimes editing a property will have ramifications outside the property itself. So I like having a method that's a little bit more explicit. That being said, there's nothing wrong with not using automatic properties when there is an invariant that you wish to enforce. If you wanted to, you certainly could use automatic properties for everything but name and allow name to be set and have your validation code inside of it. There's nothing wrong with that.
As a general thing, because you're much safer using putting functionality in a method rather than in a setter, generally, or a getter, in terms of just even if it's only you coming back to it 6 months later. You know, if it was say number of doors, the property in the getter, it multiplied by 10. Nothing tells you that. You're far better off with a method called, get 10 times number of doors. It's easy if you start putting too much functionality inside getters and setters, you can forget it's there and then wonder why you're not getting what you should be.
Yep. But again, it's a style thing that really depends on the situation. There are instances. I mean, let me think.
Occasions, you mean?
Yeah, occasions when that's appropriate. But even then, Gavin, you know what I would do instead in that case? Probably, I would use a property, but the property would return a special object that I create that has a method or a property on that allows me to represent that data in a variety of different ways. You know what I mean? So you say get number of doors, which is an actual type itself, and I can say, well, I want number of doors in the exact amount now. Now I want them times 10. So it would be car.number of doors by 10, for example.
Yeah.
Something like that. But yes, you can see it. Update name. I know from last week, but does throw new argument null exception exit out? Or just put name into the name field? Yes, if this if statement is executed, the program will crash, which is exactly what we want it to do. Any chance of a break?
Yeah, we can go ahead and take one real quick, and then when we get back, we'll just take a quick 5-minute break. How about that? Nelson?
Alrighty.
But 5 minutes. We've still got to talk about static, and then I think that's it in homework. But if people need a break, we'll just make it a quick one. I'm not going anywhere. I'll be right here. I'm going to go ahead and pause the video.
But
Okay, and we're now back.
So code. Any questions? Any questions? Because we're about to move on to something completely different, or not completely different, but still going to okay, so I guess yeah. Static. So let's talk about what static is. Static is a modifier. It's a modifier we can apply to classes, structures, members, meaning methods and fields and properties. And it really does change the behavior of things in a very significant way. Now, what we have here, because none of these things have the static modifier, they are called instance members. Each one of these are instance members. This is an instance member. Same with this. Same with this. They're all instance members. What that means is that these methods and properties are attached to every object that is created, and they're unique per object. You'll notice how this car 1 is completely independent from this car 2. They have different fields, different properties, different methods. And each one of those methods and properties and fields are independent from each other. But what you can actually do is you can declare a field or a member to be static, which means that field or member is available to every instance of the class. Alrighty. So what happens not that I would ever suggest anybody does this.
We're missing an argument.
Argument?
In your right line.
Derp. See, F# would actually throw a compiler error in that instance. Okay, so watch what happens when I run this. We get a build error. Oh. We want this to be public. So what happens now? Look at this. There are 1 cars. There are 2 cars. What's going on?
Very bad grammar.
Excuse me. I couldn't get to the mute in time. Thank you, guys.
There.
No. There are one car.
No, come on now. Let's because we're gonna muddy the waters up too much.
Sorry.
I tried. Okay, so there are one car and there are two car. So you'll notice that this variable is being being incremented every time that we instantiate a car, which is kind of weird because normally all these fields are owned by the object that we instantiate. All the members are owned by this keyword, this dot. But in this case, what we have here is a shared variable. This variable is shared between, or this member specifically is shared between all instances of car. In fact, because it's public, we can actually see this property by just doing car dot. We don't need to instantiate a car to get access to this property. And so if we go ahead and run this every time after every single instantiation, you'll notice 0, 1, 2. This variable gets incremented every time that a car gets instantiated. And because it's shared, you get the same variable for every instance. Or more specifically, the class itself owns a specific variable. So that is why main is static. If main was not static, we would get a build error because it says it does not contain a static main method suitable for an entry point. The reason is when this program starts, class program is not instantiated. Static void main is shared entirely. It is a static method. It has no concept of instant state. This is also why if we put a field on program and do not add the static modifier, actually I'm not going to show initializers, you'll notice we get an error. We'll say an object reference is required for the non-static field, method, or property console application 1.program._mynumber. That is why every field and every method that we put on the class program that is accessed from the main method must be static. So this must be static because otherwise there's no way for us to access that field. So again, by declaring a static member, this member is shared between, there's only one of these. There's only ever one of these. There will never be multiple number of cars. It is shared between all instances of class car. Now, does that make sense? Yeah, static is like only having one copy. Any questions? Should number of cars be set to 0 like good practice? Yes, but the only way to do so in this case would be to implement a static constructor, which we're not going to be talking about because there's a lot of special rules about static constructors. In addition, we have not talked about field initializers yet. And the reason is there's a lot of rules that have to do with field initializers. I actually avoid field initializers as much as possible because they do not behave the way you'd expect them to in the context of inheritance. And I think they look ugly. When do you want to add in static properties and methods? You already know what I'm going to say, Jason.
I do. But then please make sure you turn around and point out things like console.
Okay, yeah, that's a good point. I rarely use static members. I use them as little as possible. The reason I avoid static members is that because they're shared between every instance of class car. Think about this.
Go back up
shared
to main real
state.
quick. There you go.
Well, I am going to point out this because this is a good example of a good usage of static members. But I want to point out why I would avoid static members in general. And the reason is because conceptually, when you're working in a programming language that allows you to edit variables, and you have other pieces of code that relies on those variables being set properly, you introduce the possibility that your program can be in an invalid state at a different time in execution. Every time that you have a static variable that is required to be set to a certain instance or a certain value at some point and is dependent on between multiple copies of that same class or the same object instantiated from the class, you introduce the possibility of bugs that are hard to find, because let's say you have that static variable being assigned to an invalid thing halfway through your program's execution, or maybe if your program only runs for a minute, or maybe under this very specific scenario, the more shared state that you have, the more potential for bugs. That's why I've avoided talking about instance fields up until this point, because adding additional state to the class program introduces a possibility that you will get lost, and those variables might not be set to proper values at certain points. The entire idea of a class, of instantiating a class, is to self-contain or to encapsulate state to make sure that it never becomes invalid. By sharing state and allowing other objects to edit shared state, you open up the possibility that your program will come into an invalid state at some point and crash at an undefined location. I prefer staying away from static members because they allow that possibility to happen. In addition, they reduce the flexibility of your classes because you will often want multiple copies of a class to run simultaneously. Even if you design a class in such a way that this class should never be instantiated more than once, there will be times where you will want to instantiate that class more than once. So there is a design pattern called the Singleton pattern, which does help a bit in that case. You're still using staticness, but you still allow your code to be written in such a way that could be easily refactored to not use staticness if you decide that in the future you want more than one instance of your objects. But even then, the goal of an object is to be a self-contained, encapsulated example of good, proper state that cannot be made invalid. And staticness, it makes things very difficult to reason about. That being said, I've only been talking about static state, or specifically static members that change. Static members that do not change, or static members that do not rely on external state, are perfectly valid, and in fact preferable. For example, console.writeLine does not rely on the state of any other part of your program to run properly. As a result, it's a good example of something that should be made static because, well, it makes things easier to see and reason about. Let's say that you had a method called add. This method is what's called pure. The reason this method is pure is that it does not in any way rely on external state. The only variables that it can edit inside of it, or not edit, but the only variables that it has access to inside of it are the variables you passed in as parameters. Therefore, a method like this is a prime candidate to be static because in no way should it rely on any instance state to operate properly. And it's very difficult to make this add method break in the future. There's no way that changing the state of the program will ever cause add to break because it's pure. It does not rely on anything external. It does not edit anything external to itself. It's self-contained. So it is a prime candidate for staticness. So stuff like that, or let's say you have a constant value that never changes, and you can't use the constant construct in C#, which I know we haven't talked about yet, but there is a constant construct in C#, but const cannot be used for certain types of things that you might want to use it for, specifically instance classes. If you want a constant instant class, you cannot use the const keyword with it. What we could do is create a static read-only field of that, which would accomplish the goal of making it read-only, would not introduce the possibility of future bugs, and could be a very convenient shorthand in a lot of cases. So although I condemn using staticness for situations that are more appropriately handled with instance classes, they certainly have their uses. And you can see examples of that right here. Console.WriteLine, for example, or add. Is there anything you want to add to that, Jason?
That was actually very well.
Modify
No,
what
that
I
was
said?
well said. That's why I wanted you to point out console, like write line, read key.
Yep. So these are all static. And the reason we know they're static is we do not need to instantiate console in order to access these.
So with your number of cars, hang on one sec. Sorry, with your number of cars, presumably you'd rather have a, I don't know, a garage class.
Mm-hmm. Yep.
That has the, okay, right.
Yep. If I wanted to replicate this behavior right here, I would do this. Yeah.
Would you actually, given that you've added the list in, would you actually just ditch the number of cars?
Well, yeah. Well, it's like what? Oh, right. We have 1 cars, we have 2 cars. So now you see, in this case, what we've done is we've created another area that we can use, awesome behavior, and another entire class that we can put methods on it that are appropriate to this specific purpose. As a result, we no longer rely on the staticness, but we can have as many garages as we want. We could create another garage, for example, and get the number of cars from it. The code has been made instantly more flexible and more robust than it was previously, although it does the same thing. If I can ask a question, how would you want to deal with passing fields into methods inside of a class? Do you always want to pass the internal fields into an internal method parameter? You wouldn't want to, if you have a private member of your class, you would not want to have to pass in the fields around. You would want to access the fields directly from within the method itself.
Okay, so we're just over 3 hours of recorded content. So do you want to go ahead and shift gears talking about homework?
Sure. So in the last homework, let me go ahead and pull it up. Actually, can I show one more example, or are we really out of time? I just want to point out, I just want to write one more class here. And the reason is you'll notice how we created these two classes that correspond to something in real life. Both of these things are physical objects that we can reason about very effectively as humans. But that's not the last thing that's not the only thing you're going to be doing with classes. For example, you'll notice that this method right here is not very robust. There are a lot of situations where we won't necessarily want to write out to the console. Maybe we want to display the car to a file instead. Well, what we can do is remove the method from this class and actually create another class that does not have a real-life corresponding object. Let's call this car presenter, and let's give it a public void display to console that takes in a car, and we'll simply say console actually, I'm just going to do that. And then we're going to do car.name, car.year, car.number of doors, car.color. So we've effectively taken out this tightly coupled concept of writing to the console, made this class more robust because now it can be used in situations where we aren't wanting to print to the console. And we now move that into another class that we can edit independent of the car. So to use this class instead, we can go ahead and say car presenter equals new car presenter. And instead of saying car1.display, you can simply say presenter display to console car1, and then presenter display to console car2. So the point here is that we can create classes that do not have a corresponding concept of the real world. You really have to think about that in situations where you need to represent logic that doesn't have a real-world correspondence, because all too often people will simply write another method on the program class, for example. But you can still use instance classes to perform these sort of operations, and it gives you a lot of flexibility. And like Segvald said, it took me a long time to start thinking like this. That's why I just wanted to put this in just as an aside, just to get people thinking about how they can use object-oriented programming to do stuff that might be non-obvious at first, but could lead to significantly more robust code. Okay. Is anything else about that, Jason, or on some homework?
Except I'd have probably called it something like car console presenter.
Yeah, well, normally I would create an interface called iCar presenter.
Yeah, but I can't mention that right now because they don't know that at all.
That's okay. So this was last week's homework. We're at a basic product inventory system that allows the user to enter product names and product prices. Program will load the data. Program will allow the user to enter new products. Program to use enum subtract state and should use different methods correctly. Well, not surprisingly, we're going to do the same thing, but with classes. So I really want to, I don't know how much I should spell out in the prompt necessarily. But it would be really cool to see people and see how they approach taking this code and using as few static methods on the program class. In fact, you know what I'm going to say?
What's that?
Are you talking to me, Jason?
You said you know what I'm going to say?
Yeah.
And I said, what's that?
You know what I'm going to say? I'm going to say this. We factor week 5 homework to make use of instance classes. The only method in the program class must be main. Prefer to separate the concept of storing product data, or let's say the following concepts: storing product data, reading product data, writing product data, getting input from the user, and displaying product data. And, well, no, I won't talk about that. What else should I add? Any ideas? Actually, method line counts
limit it down to 25. Oh, 30. Still
30.
being generous.
I'm not that mean. Yeah, it really should be 25, but I mean, methods should really.
30 is still pretty daggone big, but you know, I'll let you make the call. Yeah, 245. Nice.
Yeah, not counting. Well, how about saying not counting comments?
Okay.
Because I know a lot of people are commenting the code to remind themselves of different things. So, and the reason I'm doing this, this practice will be very difficult for people, but it's very, 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 very important.
It is. We also have a couple questions that have come in over on the panel. A few questions.
What about white spaces? See, on one hand, I want to say no to I want to say this does count white spaces, but on the other hand, I don't want people not using white space just to fit within this limit. So I'll remove white spaces.
Should make it 20 then.
No, that NATO would kill me.
And then there's still a few more questions.
Spelling, I know I suck at spelling. If this is somewhat unrelated to what we're talking about now, you don't have to answer this, but in week 5 homework, I used a public field to hold the state of the program, which was an enum. Is that a poor use of a static field? Well, ask yourself if you needed that field. Because if you did need that field, then you're introducing a situation where multiple methods are responsible for checking that field for a value, instead of the main method I'm not going to do this word right, so I'm going to choose another one.
Arbitrarily.
Well, I was like arbitrating. Is that a word? That might be a word. The main method is the arbitrating. Okay, so the main method should be arbitrating which other methods it invokes based off of that field. And if you give the responsibility of other methods knowing about that field, then you introduce brittleness in your code. Raymond, I think I did answer. I never asked if I answered your question because I think I kind of went over that really quickly. Do you want me to answer it again, or were you good? Okay, so
as for a future class on design patterns and algorithms, yeah, that would be fantastic, Florin. We would definitely like.
Yeah, that'd be
lots of fun. Something we'd like to do. Okay, and we're about to have to go ahead and wrap things up. Let me go ahead and announce this real quick, and that is I'm going to leave it, everyone here, for you guys. It's your responsibility to make sure you check the calendar, the live classes calendar for next week, and I will publish the different times I'm going to make available for our testing.
Dees2 asked, can you talk about string.isNull or whitespace equivalent for ints? Integers cannot be null, and they cannot be whitespace. So you're pretty much going to have to you're going to have to check for 0 manually. So you're going to have to say something like if year is smaller than 0. If it's negative, then you would throw a new argument exception for that. There's going to be no I haven't looked. I mean, there's really no methods on the int class that are going to allow you to do validation like this. The isNull or whitespace method is very nice because it checks to see if the variable is null, which strings can be null, but integers can't. It also checks to see if it just has space or tab characters in it or new lines in it. So it's a very handy little method.
It's particularly handy in conjunction with stream reading and such like.
Yep. Right.
Oh, can you copy me that homework before you?
And real quick, David, just to let you know over on the questions panel, you haven't heard anything about your homework. We've talked about that pretty much each week now, and that is homework that is submitted, that is passed. Because of the sheer amount of homework that we get in, we just simply do not have the time to address each person and say, hey, good job, you passed. If you fail, or if you have a problem that doesn't result in a failure, but a problem with your code that needs to be pointed out, then you're contacted. So if you haven't heard anything, then you're in good shape.
Well, David, what's your username? Is that Brislin? Yeah, I didn't. If you're referring to, I don't know which homework you're referring to. I sent out PMs to everyone who had submitted homework for up to 3 and 4. I don't recall seeing a homework 4. The Trello board was something that Zach was dealing with from his end. I'd kind of forgotten it was there.
And I know nothing about that at all, so. Voodoo Hoodoo, take care.
Sorry, can't talk and read at the same time.
And Rowdy, I saw you just a second ago say something about don't let the attendance drop in the C# class. Don't let the attendance drop the C# class. No worry, Rowdy Bull. That's not going to happen. This is one of my favorite languages. It's not going anywhere. It's just going to get more and more fun. So outside of that, I think that's pretty much everything. Again, let me repeat one more time for anyone that may have zoned out a minute ago. It will be your responsibility as the student to check the live classes calendar throughout the week, or just check it by this coming Friday to see at what points are going to be available next week for testing. There will be multiple times that we will meet, and you can register for all of them if you want, and then you don't have to attend all of them. Just show up for the first one, or the first one that is convenient for you. Take the test, pass the N. If you don't pass, you take the test again the next day. We're making this as easy as we can, but I just want for you to prove to us that you are walking away from the 101 class with a 101 understanding. And I'm pretty sure all of you guys are going to do it without any problem whatsoever. Can you take the test multiple times even if you pass? Oh, come on. That'd be ridiculous, because you're going to know which problems that you missed. And then if you took the test again and you didn't get a perfect 100, I would have to outright fail you. And that'd be horrible.
Brislin, I haven't seen homework 3 or 4. I've just double checked. So, yeah, that never got as far as me.
And Florum, right now we're not going to have multiple or random questions queue to pull from. Though, to be dead honest with you, I would like to get something like that in place in the future. It's a time thing. We have so many things going on, and we're trying to dedicate as much time as we can to the classes, but we're still trying to handle a lot of other things as well. So there is a point. I mean, Nelson can tell you about his desires for where BuzzNet needs to be, which is going to be fantastic, because then you guys are going to be able to see when homework's been graded, you're going to be able to see feedback, you're going to be able to see a ton of different things that you don't easily have access to right now, or plain out don't have access to. But again, it comes down to just, there's only so many hours in the day. As Segfault saying, Buzz, more language vids. Exactly. More hours in the day. to do more stuff. We just need them. But let's go ahead and let's wrap things up. For anyone that needs to get a hold of Nelson to discuss homework and all, please feel free to. And I think that's pretty much everything. Hang on one second. James, okay, good. Glad it's not really important. I've got a line, several people deep that, not students, issues that are waiting for me to get solved. Part of my fun Monday.
I was going to ask the same thing.
I'll have to try to holler at you shortly. Gavin, there's a few things I've got to get knocked out. But, okay, James, thanks.
I'll be around for a while.
Okay, excellent. All right, guys. Well, thank you guys very much. That's going to wrap up week 6. And while next week's not going to be a lecture week, it just gives you time to get homework done, turned in, so that you can basically so that Gavin can make sure nobody had any difficulties. And then a final exam, and that'll be it. So thank you guys very much.
Was that 6
Yeah,
weeks?
That's the end of 6 weeks today.
What? Where did my month go?
Gone. Over. Fast. Impressive.
Huh. Yeah.
See, you guys hang out with us. These weeks are just going to fly by. Next thing you know, you're going to be thinking to yourself, damn, I'm smart.
I did, but the C++ runs into June. I couldn't believe it.
No, isn't that scary?
Yeah.
It scared me, trust me. So I was like, oh my God, that's pure summer at that point. All right, guys. You guys all have a wonderful day, and we will talk with you guys shortly, I'm sure. Bye, everyone.
Bye.
See ya.